I'll go ahead and check the chat right after that, and if everything looks like it's good, we'll go ahead and start. Okay, test. I'm gonna check my YouTube chat really quick. I think I'm live on YouTube though, so if anyone's seeing the stream start YouTube, hey, welcome to the Game Engine stream. Just making sure everything's all the chat is working, and then I'll go ahead and start. All right. Okay, so let me check something. Okay, platforms look fine. Let me make sure my... Yeah, let me make sure this is connected. Okay, so... disconnect that, connect it back. Wants me to sign in again. Where am I? Okay, I think I'm good. Okay. Oh, it looks like okay. So let me test YouTube really quick. Just check if these chats are working. Still kind of broken. It's a little bit annoying. Okay, well usually it picks up and it figures it out, so I'm not going to worry about it too much. One thing I did want to check though was the YouTube title. The YouTube title I think is wrong. So let me check that really quick. Go live. Yeah, okay, so that's the wrong name. It's not linear allocator, it's what did I title the stream? Integrate network code. Okay, we'll go with that. Okay, I think that's fine. Yeah, I think that's fine. Let me test it one more time. There we go. Yeah, it just takes a second to pick up, but it looks like it's working. All right, let's go ahead and start the stream. So welcome to the Game Engine stream. Today's Friday, another Friday, April 4th over here. Yeah, all right, let's go ahead and start. Okay, so today I will be working on integrating networking code. So I've been working on code in the network playground for a while. I've kind of reached a point where it's ready to start integrating, and I have actually started integrating in the previous commit, so I'll go ahead and show you guys that progress. In the last stream I was working on a linear allocator. That's basically done. I also added a pool and a stack allocator as well, so I'll go ahead and show you guys that real quick. And then we'll go ahead and get on with the networking code. Yeah. But yeah, that's pretty much it for updates. Nothing too crazy. That memory stuff, I just wanted to get those allocators created, and then later on when I find some applications, I can go ahead and use them. Yeah. All right, so let's go ahead and check out the progress board. Yeah, I was working on memory allocators. I guess this is done. What was I adding anyways? Yeah, I mean, this is all I was going to add, so... I would call this done. Maybe let's, actually set it as completed. Moving my mic really quick. Let's see. Okay. Cool. So that's good. And yeah, we're still working on this UDP network thing. And last time, yeah, I was working on getting simple UDP BSD sockets working, and then after that I was going to migrate the networking code into the engine, so that is today, right? So yeah, it looks like we're right on line for getting this done. Let me see if there's anything else I wanted to say before I started showing the progress. Yeah, I don't usually really recap the previous stream. Or, you know what, I'll leave it, fine. Okay. Alright, so I'll just go ahead and showcase what I got done before, and then we'll go ahead and continue on. Working on networking code. So, where do I start? I guess I can go and look at the diffs. Oh, but you know what? All the code is already integrated in here. Okay, so right now I'm on a network branch. I guess I haven't shown this. I added a memory branch and a network branch. These were both for their respective work, right? So the memory was me adding the pool allocator, the stack allocator, and the linear allocator. And the networking code is me finally integrating in the network playground. And again, I already started doing that. So let me go ahead and show the memory code I worked on. There's nothing to actually, how do I say? There's nothing in the runtime I have to show for that. All I'm going to do is just go ahead and show you the actual code and kind of explain it a little bit. So for the linear allocator, I already did most of the work last stream. I believe I just finished up cleaning up some of these extra functions, but I'll still run through it anyways. So basically, the linear allocator, right, I tend to not do too much inside of my constructors and my destructors, so that didn't change here. But the main thing is this init function. I don't even think terminate does too much. Yeah, it just clears some of the variables. But basically what init does is you call init with a backing buffer and a buffer size, and it is, you know, it associates this allocator with this backing buffer, right? So this is something that you would either like malloc, or in the case of how it's going to work in this engine is I'm going to have a bigger memory buffer that I'm going to allocate memory from the paging API, either from the virtual alloc or the mmap, which if you saw my previous stream, I believe it's What's Up, and I forget his name. I think I have him in the chat. Emblem Gzewski. I'll keep calling him Mblack, but he helped me a lot with telling me about different aspects of linear allocators and whatnot, or like memory allocation, and yeah, What's Up also helped me a little bit too, so that was really nice. But yeah, I forgot what I was going at with that. But anyways, basically you associate this linear allocator with a backing buffer, and that backing buffer can either be like a new malloc. Oh, you know what, I remember what I was talking about. Or you're either getting page memory from the operating system, right? So when I finally integrate this properly, I am going to use the paging system. I just haven't properly used it yet, or properly integrated it yet. So at the moment, I am just using this gen alloc, which is just a wrapper around malloc. Yeah, here we go, malloc, right? I even put a note here saying, would you please add virtual alloc or mmap? So if I go to page alloc, you can see it links me to either the Windows variant or the Linux variant, right? So if I go to the Windows variant, nothing. I just have an error here. And same thing for the Linux. It's supposed to be mmap here, but it's still an error. So once I actually start using this in the engine, I will fill this out and start properly using it, but for now I'm going to leave it alone. So the current API is you would call gen alloc. This would give you some memory that you're supposedly opposed to free, right? Probably should add an API for free as well, but I haven't used it properly yet, so I haven't really bothered. But yeah, you call init. The init function associates this allocator with this backing buffer. And once it's associated, now we have a valid memory to associate when we allocate an individual piece of memory with this allocator, right? So this allocator is now alive with this init function. And we allocate memory into this buffer using these functions, either alloc_raw or this templated alloc function, right? And here I have a link to the actual article that I used to create this allocator, along with the other two allocators I'll show you. But this kind of takes you through the whole process. I've tweaked my code a bit to be different from this, but for the most part, it's pretty similar. So yeah, I'll put a link in the chat. I also usually put a link to these articles. How do I say? Inside of my description of the video. So if you're watching on the video, you should see it as well. But yeah, basically the linear allocator, all you do is allocate. You don't ever free individual memory, right? The only time you free memory is when you actually reset memory. That completely clears the memory. In actuality, it doesn't actually clear anything. It just sets the offset to 0. But this is a pretty fast operation, and there's no need to clear it unless you were doing some debug information or something like that. But yeah, this is basically the big meat and potatoes, as you would say, of the allocator, right? So the alloc_raw just takes in a data size and an alignment, right? The alignment is important so that memory access isn't unaligned. That can cause UB, undefined behavior. I forget that's what that term stands for. But yeah. Also, it's just slower memory access when memory is unaligned. So you want to make sure that it's aligned to whatever type you're providing. So basically, this alignment will align whatever data you allocate, right? So if the data is 4 bytes aligned, right? And the current location, the current offset that we have is not aligned to this alignment, it will move this offset forward a bit so that you can allocate the memory in the correct alignment. Yeah. Specifically, all this does, if we look at the function, we get the current offset from the current buffer, so that's the current data pointer, right? And then we call this align forward, which when we open, basically just takes whatever alignment it's at, and shifts over the pointer to this new return pointer. And the way that it does that is basically it calculates a modulo, or the remainder. And this is basically the difference, like the distance between the current pointer and the desired aligned location, right? And then if there is no remainder, then we just return the original pointer because there's no need to align it. It's already aligned. But if there is a remainder, then we move it over by the additive inverse of the modulo, which is fancy terms for just saying instead of adding the remainder, we add the alignment minus the remainder, which is the the remainder of the subtract. Yeah, I guess a lot of remainders in that sentence, but if you read the code, you can kind of tell. If anyone has any questions, just let me know. I can explain it in more detail. But long and short of it, this aligns it to the correct offset. And then here, basically we, how do I say? Offset minus equals M buffer. Oh yeah. So this gets the distance between the buffer and the offset. So that's the new location we want to deal with. And then now that the offset represents the actual location inside of the data buffer, we can go ahead and allocate off of that offset, right? And that's it. Yeah, we allocate off the offset and then we return that value. Make sure to update the offset. And then we're good, right? Actually, hold on. I think I just spotted a bug. No, this is supposed to be just offset. Hey, there we go. Fixing bugs, aren't we? Yeah, it's supposed to be this offset, not the M offset. M offset is used to calculate the original pointer, and then we move the pointer here, and then this offset is what we actually want to allocate off of. So yeah, that was a bug. Hey. All right, well, I'll test that later. But anyways, that's the long and short of it for the linear allocator. Again, there's no free operation. You only reset the allocator, because that's kind of the intention of a linear allocator, is that you only allocate, and then once you're done allocating, you just free it all at once in one big chunk. And this function is basically just a wrapper around the alloc raw, but you can provide a templated type to it, and then it automatically calculates the alignment and the data size based off the type. So this is the size of, you can provide an optional count. I think mblek provided that for me. So I figured why not? And yeah, alignment is calculated based off the alignment of the type, right? And then again, we just call alloc raw and then do the same stuff, get the memory back, and then move on with your day, right? Okay, so at a high level, the linear allocator is just a data buffer and then an M offset pointer, right? And as you allocate data, you move that offset forward. And then once you're done with that data, you free all of it at once. That's all a linear allocator is. You can add more functionality to it if you want, but that kind of goes against the spirit of what a linear allocator is supposed to be, right? All right, the other two is a pool allocator and a stack allocator. And the only significant difference between the linear allocator and the stack allocator is that you do want to free memory from the stack allocator, but only from the top, right? So the linear allocator, you're supposed to allocate memory and then that's it. But the stack allocator, you want to keep track of how much memory your most recent allocation was, and then if you want to pop that memory off the stack, you can go ahead and do so, right? And in order to do that, basically, the lifecycle of this is exactly the same. There's some different helper functions I'll show in a second, but there is an actual free. And here, this free operation can actually be done at any point in the stack, so you can actually take off multiple chunks of memory at once, right? But the intended case is that you usually drop one piece of memory at a time in a last in, first out sort of way. Yeah. But the init is exactly the same. You're still setting a backing buffer. You're still providing a buffer size. The only difference is we have a current offset and we have a previous offset. So the previous offset allows you to keep track of the size of the memory going back, or where the location of the last memory was, so we can easily fall off the stack really fast. And actually, that kind of reminds me, maybe there's a bug here. Did we use previous offset anywhere? Let me highlight this really quick. Oh, we don't even use it. Interesting. I mean, yeah, that would make sense. Yeah, you would just update, but I've never seen an actual read operation from this other than setting it itself. Interesting. Okay, I'm just rambling to myself, but yeah, I guess this previous offset's kind of useless right now. Now that I'm looking at it. All right, well, anyways, let's just look at the allocation. So here's the alloc raw, right? Same deal as before. You have a allocate, and then this is a wrapper around alloc raw, does the exact same thing. But here we have a different structure. So basically, truncate alignment. Actually, give me a second. Let me go ahead and read this. I think I wrote this code a week ago, so I'm trying to remember. Okay. So basically, this does pretty much the same thing as the previous allocator. The only difference is we're storing a header along with the allocation. So if we go to wherever we do the alignment, this top part, I believe up to this point, is basically the same thing, except for these extra variables we have here. From here to here is all the same, right? So we're calculating the alignment for that data. But now we need to take into account the header, right? So you can read this or take a look in the code if you want. I'll have the commits available. I know there's a lot of comments here too, so you can kind of take a look at what it's doing. But basically, it's just making sure that there's enough memory available for the header. And then if there's not enough memory available, it adds some memory. And it adds it based on the current alignment, right? But yeah, basically it's just adding an extra bit of padding to it so that the header can fit inside. That's all this does, right? So if we go back, now we know we have enough memory for, or enough space for the alignment, as well as the size of the header, because we're gonna need both of those, right? And now that we do, we just do the same thing as before. We just get the new allocation pointer based off of the padding we need. And then, yeah, we return the actual data pointer. But this time we go ahead and pass in, or we create a stack allocator header. And then we located it right before the actual data pointer. So this next pointer is the actual location of the data. And then right before it, we just prepend this little header that basically tells us like where the previous data is, and that way you can sort of recurse back all the way back and get that like stack functionality that you want. These are basically the way that you figure out where each of the data is going backwards, right? But yeah, still you return the next pointer and then you move on with your day, right? Okay, so I think out of the three, this one's the most complicated. And again, if anyone has any questions at any point, just let me know. I can talk to you about it if you're curious. I was gonna make some videos better explaining this, but I was having some trouble with my video software, so I might shelve that for another day. But yeah, I realize my explanation is not the greatest for this one. All right, but anyways, let's continue. Here's the pool allocator. This one I would say is probably the easiest one, or maybe the second easiest one next to the linear allocator. This one basically, instead of having various sizes that you can provide as memory for allocations, there's only one size you can actually provide. And that's kind of what makes the pool, right? So it's a bunch of chunks of equal sized memory. And with this memory, you can actually free memory at any location and it doesn't have any ramifications anywhere else, right? So you can free a specific fixed size chunk of memory, and then you can reallocate that memory and then continue, right? You know what, let me draw something just to explain it, because I feel like It doesn't really get communicated without it. Let's see if it'll open. It's taking a minute probably because of the... Oh, no, we're good. Okay. Okay, so real quick. Let's do this, and then I'm going to do a text linear alloc. Okay. Okay, let's make like a fixed size chunk. Okay, and then maybe I can make a color for this. Can I? Yeah, let's do that. Okay, and then also let's add like a arrow. Here we go. Can I make this bigger? I guess not. Hopefully you guys can see that. Actually, maybe let me do this one instead. Kind of like this one. Okay, there we go. So here's a linear allocator. Let me copy this real quick and bring it down to a pool alloc. And then here is a stack alloc. Okay, real quick. So the linear alloc, right? You can basically allocate chunks of memory, right? And then they don't have to be any specific size, and all you need to do to keep track of where you want to allocate next is this pointer, right? So if I don't have this here, the pointer is going to be at 0, right? If we add this, don't mind the funky arrow. If we add this, we're going to go ahead and move the pointer over. And that whole alignment thing is making sure that the data alignment for the memory access isn't inefficient. So one thing we can do, right, is we can add this right here, right? When we add this memory, we want to move it forward. But say this is like I'm gonna put this right here. I'm gonna say 4 bytes. Okay, all right. This is 4 bytes, right? So this one I'm gonna say is one byte. Okay. For 4 bytes, you want it to be aligned in 4-byte chunks, right? Because that's good memory access for this one. But you can see here, it's actually aligned at the 1-byte chunk. So what we do is we move it over until we get about 4 bytes of padding. And now, well, if we move it over here, I'd say it's about like that. There we go. So now that we have this padding here, these 4 bytes are now aligned in the memory access, and then we can access it like with it being aligned, right? And again, that has benefits for performance and whatnot. So I'm not going to get into that, but yeah, that's basically what this little chunk of empty space is. That's that padding. But if you forget about the padding and just worry about the data access by itself, basically you just put the data together and then you move forward, and then the offset gets stuck right here. And then when you add more memory, it adds the memory, and then you move the arrow over, and that's all a linear allocator is. And then when you free, you just move the pointer back to the front, and then now you can just allocate memory. They can basically overwrite this, and it's fine. The pool allocator is a bit different. The pool allocator, you have, I'll put a little bit of spacing. Don't mind the spacing. It's just so you can kind of see it. It's not padding, it's just, I'm just kind of putting it there so these are distinct. These are distinct, yeah. Okay, you know what? Spacing's not really open. Oh, you can see the lines anyways. Okay, good. Okay, so you can kind of see we have fixed size blocks, right? And then basically what we do is when you allocate some of this memory, right? And actually let me make one more little bit. We're going to call this a header. I'll put a big H right here, so I can really show you how this allocator works. Because it's kind of interesting, like this specific allocator has like a very specific functionality. Because this uses a free list, right? And let me kind of explain that. Okay. So, the way the free list works, in this case, it's actually like an inline free list, which is kind of nice. So we have a header, right? We put this header here. Let's go ahead and get it right there. And these headers are actually spaced alongside with these, right? So I can do this. I don't know if these are perfectly spaced, but I hope you guys get what I'm saying. Yeah, it's not perfectly aligned. But anyways, we have these headers, right? And these headers, basically, they point to each other, right? So this one points to this one points to this one, this one points to this one. I could put some arrows here, I guess. Like that, right? And it goes all the way down to the end, right? But these headers don't actually contain any memory other than their pointers to the memory, right? And this one points to nothing. I guess I'll just make it not point to anything. And basically what happens is when you allocate something, we drop this header. This becomes like the new like fronts of the headers, right? And this memory gets allocated, right? And then we continue this pattern, right? So we get rid of this. We get rid of this software. Oh wait, give me a sec. I think I heard something. Okay, I'm back. There's just a thing popped up real quick. Okay, so yeah. We move this pointer over. Now this is the head of the list, right? So when we want to allocate, we reference this one, right? And then we put this memory here, right? And then we just continue doing this until this whole thing is allocated, right? But if we free something, basically we take this one out, we move this header over here, and now basically we do this pointer thing where we point over to, I can put it on top here, over here, right? So now the next time we want to allocate, oh yeah, and then this becomes the head of the free list. There we go. And then now next time we allocate, we're going to allocate from this one. We'll get rid of this, and then move this data chunk over here. And we're going to move the pointer over to this one. And now this is the next one to allocate. And that way, if you have a bunch of holes, we can always be certain that we're filling the closest to the left chunk of memory, right? Yeah, and then once you fill this entire thing, which you could do like this, maybe get rid of those H's. Yeah, but once the list is completely empty, there's nothing to point towards, right? So when we add a new Basically, this is basically pointing towards null, right? So we're going to add back a piece of memory. We'll add that h back there, right? And this will become the new head of the free list, and it'll point towards null. This doesn't point towards anything, and then we can just continue adding back. So it keeps working no matter what. And this really only works because we have fixed size chunks. There's other memory allocation schemes that they have. They have like slab allocators. You can do, what was the other one? It uses a linked list. Oh yeah, it's a free list allocator, which is different from this because this uses a free list, but it's still a pool allocator. There is a specific free list allocator that works with like varied size memory, and you can like allocate and deallocate in the middle, and then just go from there, I suppose. But that one can lead to a lot of fragmentation. This doesn't lead to fragmentation, or at the very least, if it does, when you add new memory to it, it will unfragment it. The free list version, you end up with persistent fragmentations unless you remove the memory around, but usually that's not really a thing you can do with memory management, so you're kind of stuck with the fragments. But yeah, that's the kind of long and short of it for a pool allocator. The stack allocator, like I said, there's a header that gets associated, but this header goes with the data, not replacing it, right? So you would add the header, and then you would also add the data in front of it, right? And then let's make this one a bit smaller. And we'll put this header right here. And basically, all these headers do is they point back to each other, right? So we know this is the current location of the memory, right? This is where we want to allocate next to. And we have stored the previous location, like where this is stored. And this one stores this location, right? So basically, when we free this one, we drop this one, put this over here, and then our previous, in this case, becomes null, right? But if we had a big stack of them, they would just go back, go back, go back, and go back to the end. That's basically how the stack allocator works. And then when you allocate, you put this little header here, you move this pointer up to the front, right? And then you point this back to its previous, right? And you just keep doing that until you've run out of memory. And yeah, a lot of those operations that you saw in the code, that's basically what was allowing this header to be available and make sure that it's aligned properly, right? Right. But yeah, that's basically it. So you can kind of tell what the pool allocator does at this point. Hopefully, I don't know. But when you create a pool allocator, you need to specify the chunk size first, right? So because the pool needs to be aware of what the fixed chunk size is, right? So I provided two inits. The first init, you provide the chunk size explicitly as a number, and also the alignment explicitly as a number, right? But you still provide the same backing buffer size. But here you do a little bit of work at the beginning to go ahead and figure out the alignments. And then using that, how do you say? Actually, let me take a look at this real quick. Let me make sure. Okay, no, I get what's going on. Yeah, so basically you have the backing buffer. This just aligns, say if you provided a backing buffer that wasn't aligned for some reason, I don't know why you would, but this is just like a fail-safe for that case. Basically, you provide the backing buffer, you associate it, right, with this buffer, and then you make sure that the chunk size is aligned with this backing buffer. And that's where you put the current offsets, right? Or in this case, we call it a head node, right? And after that, you can just start adding memory. And then here is this reset. This reset is a bit different. Basically, it's takes all the memory and then puts all those headers back. So if we go back to the little demonstration of this, if I get rid of all these, basically this is the state you want to start at, right? With all the headers lined up, and then you're going to be replacing these. I don't know if that's perfectly aligned, but you get what I mean. So and then you want to point this to the front, right? So now you can go ahead and start allocating memory. So that's basically what this function does. It looks through the buffer divided by the chunk size, and it just makes sure that you add a free node pointer, which again is just a pointer to the next node. And then you go until you fill up the entire buffer. And again, we can do this because we know the fixed size of the buffer. And the fixed size of the chunk. Yeah. And basically that sets up the free list. And then the allocate actually becomes really easy. All you do is you look at the current header node, right? You return the current node's data, like i.e., you return this chunk of data right here, right? And then the current node is aware of the next node, so you assign the head node to the current node's next node, which, if that's confusing, basically you're just taking this pointer and moving it over here. And then you just return the memory, and then that memory can be overwritten with whatever you need to put into that chunk, right? Oh yeah, and then if you go back to the init function, basically this init function just wraps the chunk size and alignment into the template type, right? So if you have a particular type, you don't have to worry about its size or alignment. You just provide it, and then you can just start storing those chunks, right? But if you just want to explicitly worry about the buffer size yourself, you can just do this here, and then not worry about it. And of course the standard alloc and free. But the free is kind of interesting in this case because, of course, we want to find the head of the free list. And then we want to add a new node to the free list, and then that new node is going to be the new head. And then its next node is going to be pointed to the current head, right? So that's this part. And then assigning it to the head is this part. And this is just a bunch of checking to make sure that the data pointer is valid, and we know we're not going outside the bounds. That's about it. There's better ways to handle this too, so I'll think about that later. For now, it's just an assert. Yeah, and that's basically it for the allocators. Again, I know that wasn't like the greatest explanation of this topic. There's a lot of good videos on YouTube explain this type of thing. I was planning on making a video for this, but again, I had some issues with my software that I was using, so I'm gonna push that on for another date. But yeah, that's basically the memory allocation. I didn't know it would take this long to talk about it, but yeah, that was basically the changes. And the networking code is a lot simpler, or not a lot simpler, but there's not as much to talk about. So let me kind of just show you. And I can show you with the current state of the network playground. I have a lot of changes. I'm not gonna upkeep this. This is like something I did last minute. If you saw the last time I was working on this, I don't remember the last time I showed you guys, maybe it was a few weeks ago. All of this code was in separate chunks, like folders and whatnot. So I just took everything and put it into one giant folder. And then I took it and I chucked it into this network 2 folder. Now you can see this is a lot less, right? Because what I did is once I put it in here, I took a lot of the code that didn't belong here, like the loop timer. This POSIX thing goes in a specific API section I can show you. The string operations, the threading, the bit field, all of these don't belong here, so I just moved them out. I also got rid of the logger, and I switched it back to like my actual in-engine logger, so this isn't a thing anymore. But yeah, that's pretty much all I did. So most of the code is unchanged. I just did some adjustments so that it compiles in the engine now. But yeah, as you can see, if I go to the core section, we have this. Maybe it wasn't in core. Oh, well, I have the threads are over here. Maybe I should put it somewhere else though. And in the utility, I believe I chucked a bunch of things in here, like the passive loop timers in here now. Where's the other timer? Oh, the loop timer's here too. I believe I put some of those string operations, I put it directly in here too. So just taking the stuff and putting it back into the engine. That's all I did. And yeah, that's pretty much all I've done, because that was a long recap. How long I've been talking? 47 minutes, wow. Jeez. Okay, well, yeah, if anyone wants to know what I've been doing up to this point, that's pretty much what the recap was, so I'll go ahead and continue coding from here. Is this Kargono? Yeah, it says. Let me... Okay, yeah, let me close this as well. Okay, so the goal for today is to just continue integrating the UDP networking into the engine. That's about it. So let's go ahead and do that. All right, so I think where I left off, again, I haven't actually modified the code or anything, or like integrated anything into the actual original networking code. So this all still uses Asio and whatnot. So I think my first order of action is to, I suppose, dissect this client code and figure out the points where I can start replacing it with this code. So it's going to be more of like a reading thing. So let's take a look. I believe in this section I have a client service, which I don't know if I want to keep this, to be honest. I also have this explicit run and end run thing going on. This makes sense for the client code, but I don't think it makes too much sense for the how do I say, for the new way that I'm doing this. I'm just thinking, should I get some coffee? Yeah, you know what? I think I'm gonna get some coffee, so I'll be right back. Okay, I am back. Let me go ahead and stand too. I'm gonna move up my desk really quick. Just give me a minute. Yeah, I was gonna talk while it's moving up, but it's kind of loud, so just give me a second. Okay, all right. Oh yeah, I think that coffee's waking me up. All right, and I think I had like an epiphany, or just an idea. I don't know what to call it, but I was going to try and integrate the new networking code into the old networking code, where I think it might be better to do it the opposite way. And also, this is a separate branch, right? I did do this change. Maybe I should do this in a separate commit, maybe. Okay, wait. Let me think. I'm gonna try not to fix too many things that are unrelated in this branch. I don't want to undo the changes, but I want to move it. Okay, you know what? Fix bug in linear alloc. Wrong offset used when allocating. Getting memory. Okay. I want to be careful with this diff because I'm going to start doing some very destructive things to the code. So I want to make sure I don't have anything that I actually care about in here. All right, so I think what I'm going to do, again, is just to start looking through here and just taking things that I think will be useful. Or at the very least, they're going to be needed, right? Here I do a lot of explicit stuff with this, right? These function queues, these event queues. Oh, I should add an event queue, shouldn't I? Yeah, we just have like this mutex here. I feel like these should all get wrapped up into one thing, so I might do that later. All right, but yeah, let me read this code. So, client service, this is where we actually interact with a bunch of static functions that can get called anywhere in the code, which is not the greatest thing to be honest. But I don't have any proper plugin system or anything yet, so I'm just kind of stuck with this singleton-esque situation. That's fine. But essentially, this is sort of our interaction point with the rest of the code, right? So we need to make sure this stays preserved as much as it can. And as far as I can tell, I guess I'm taking a stretch break. I'll stretch my fingers really quick. Yeah, we have a few different things this thing does. It processes the function queue, processes an event queue. That's fine. I can do that. Maybe I should make an explicit function queue sort of object. Actually, I might just do that, to be honest. We have the actual client in one location here. Probably want to rethink that, but for now I'll keep that. And we have all the events that we can call. Here's for submitting work to the function queue and the event queue. Why am I doing a const function reference? Isn't this thing only like 64 bytes? Wait, 64 bytes? What? Word? Wait, I could have sworn these are way smaller. 64 bytes for a function pointer is kind of crazy. It's a good thing I organized this recently, because without it, this would be a lot more annoying to deal with. Alright, I think size of... and let's get this thing. No, yeah, it's... wait, is it 64 bits or bytes? I'm confused. 64 bytes. That's pretty big. Oh, I didn't know it was so big. What about wait. About a... forgot how to write a function pointer. I always forget every time I need to use it. I know where I can find one. Yeah, here we go. This thing. I'm just curious right now. Let's get rid of this. So, size of... yeah, how big is this? Oh, it's giving it a name. Okay. Yeah, no, I don't care about a name. Just... okay, what size is this? Yeah, it's 8 bytes. What a difference. Okay, what if I get rid of this? Yeah, what a difference. Wow. That's times 8 in size. I always thought it was like times 2 or something. If that's the case, I probably should think about that some more. But yeah, for now it's fine, I guess. Yeah, the only thing is I feel like these SD functions function more as a, well, they have more closure functionality. Which is kind of nice. Okay, anyways, yeah, I'm getting sidetracked with that. So yeah, this is the submission. We have the events below. These are the lifecycle functions. Sure. What does ren do again? I gotta double check. It just calls this function over and over again. I already handled this, so that's fine. End ren, yeah. Okay, then what are these? Get active session slots. Send all entity location. Send all entity physics. Enable ready check. Okay, so these are just called externally. Sure. Okay. Alright, sure. So yeah, let's go ahead and preserve this. I'm going to take this whole client service thing, I'm going to move it over into the new code. I don't think I'm going to keep this, but as far as just getting it to work, I'm going to need it for a second. Let me take a look at this really quick, though. I did organize all these messages. That's nice. Yeah, it takes in a message along with its payload and then does whatever it's got to do, right? Sure. Okay, okay. open message from server, and then this is giant switch statement, which I remember they're saying maybe use a factory method instead. Instead of having this as, yeah, I'll think about it. Okay, I think the only real pain point here is going to be this session slot thing going on. Got to figure out what this is all about. Resolve local endpoint. Okay, this stuff I don't care about though. Like, yeah, this is just garbage to me. Yeah, this is all local bind socket, blah 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 blah. We're doing TCP, UDP at the same time. Yeah, I don't need any of this. So this can all get removed. Is connected to server. Connect to server. Yeah, you know what? Now that I'm thinking about it, yeah, pretty much all of this code is essentially, except for this part, this is pretty useful. But other than that, everything else can kind of get thrown away. Because I already have everything else here working on my own, or on the other type of networking code. So, okay, I think I understand now. The main thing is I need to get this client service. I need to make sure that I make this code all work. And then later I'll get rid of it, but I need to make sure that it still works so that my engine still functions. And I need to make sure that I still respond to these types of messages. And that's about it. Let me go look at the other networking code really quick. I think for UDP, connection, I think this is all garbage. Because this is just the API I use to send messages, yeah? Yep, memcopy. We do a CRC, I'll worry about that later. That's like a separate thing. Right, message async. I mean, that's important, but I'm not worried about it right now. Yeah, everything here is garbage. So I'm gonna go ahead and delete this. Let's see, TCP. What's up with this? This has a validation output. Currently, I don't do validation. I will add validation. But as of right now, I just want it to work, so. It's fine. Yeah, I will add some sort of handshake at some point. Tokens, message async, read payload. Buffer size 10 megabytes. Okay. Okay, this session code needs to be preserved though. So, yeah. Okay, and same thing for the server. So basically for the server, I just need to make sure that I preserve this API here for the service, whatever this is, and make sure the session stuff still works, make sure I respond to messages correctly, and that's about it. Okay, so I'm gonna do something a little drastic. I'm just gonna let that go away. And session server net tools. What's net tools? Oh yeah, this is this config file thing I was doing. Yeah, that's fine. That can stay. Don't know if that should be net tools. I'll think about that. Yeah, this is still useful. Although some of this payload stuff is not applicable anymore. Yeah, and this is definitely garbage now. Operator. Okay. Network context. Yeah, yeah, this is actually all garbage now. Yep. That one's still relevant. This is just some helper functions. And this is just some implementation stuff, which this is irrelevant now. Okay, let me go to the client really quick. And let me get rid of some stuff. So this is irrelevant now. This whole connection thing is garbage. So let's go ahead and get rid of it. Let me just read it before I delete it. Yeah, it's all garbage. Yeah, no more interconnections. UDP connection successful. Yeah, that's an interesting bool right there. Let me get rid of that. I don't need that. Kind of hurts looking at it. All right. This stuff's still relevant, but I have an API, or I have like a specific class for handling this, so I'll get to that in a second. Okay. Yeah, that's good. All right, let's go. Let's do the same thing for the server. So this is all garbage. No more Asio. Goodbye, Asio. Okay. Pretty sure this is all garbage too. Okay, we have an event queue. That's fine. Bunch of session data, kind of loosely held here. Should probably wrap that up into something. Okay, and the same API. That's cool. All right, get rid of this. Okay, and you know what? I'm gonna go ahead and let's just get rid of that Asio thing entirely. So let's go to the network, go to the Asio API and get rid of this. No more of this. And I'll worry about, let me just put a note later for getting rid of the dependency. But I don't even want to see any Asio code compile. All right. So yeah, today's just I don't even know if would you call this refactoring? No, this is integration day. There we go. So lots of me yammering on and erasing stuff. So let's see. Yeah, you know what? Let's get rid of the Asio dependency. So let's go to dependencies. We're just going to delete this. And let's go to my pre-make files and get rid of it too. Administrator, huh? It's doing that thing, okay. That's fine. Just delete the files themselves. I could just use a console command, but I don't feel like it. Okay, no more docs. There we go. That should delete now. Alright, no more Asio. That's good. I think it's in my dependencies, Lua. Let's see. What's in here anyways? No. Okay. Okay. GLFW, glad. Asio. I see it. Okay. Good there. All right, let's check all of our executables and whatnot. So, and the engine library. Yeah, I might switch to CMake at some point. It's just such a gargantuan change that I have to kind of set aside some time to do that. But the main reason I want to use CMake is so that I can add like separate projects on my GitHub and then make them usable by themselves. And usually people like using CMake with that, so figure why not. Let's find Asio. Okay, no more Asio. Dun, dun, dun. Dun, dun, dun. Yeah, I see it right there, but I think I have this for like all of them. Makes sense for the editor, I guess. What about the runtime? Actually, why would you include it in there? I guess it's because I had it in the header for things, so it had to be included. It's so weird. I was also thinking about C++ modules, but I know it's a very new thing to add, so I gotta think about it. But it would be very nice to be able to specify what you export out of a specific module, and then you don't have to include that stuff in like a header situation. So I was thinking about that a little bit more recently. Furious Elk, yo. Is your comment popping up on the screen? Oh, it is. Okay, cool. Yeah. Good afternoon to you too. Is it afternoon over there for you? For me, it definitely is. So I appreciate it. Oh, here's Asio. Yeah, I'm just getting rid of some, or what do I call it? I'm integrating the networking code into the engine that I've been working on. So, big restructure day. You said a code sharing system? What do you mean by that? Where is my... Okay, so I think that was the runtime, that was the server. And the editor. Okay, so let's check the testing code, get rid of Asio as well. Code sharing. What is that? You got me curious. Let's see. Asio. Okay, there we go. Code sharing. Are you talking about the build system? Like when programming in a team, you possibly will want to share the code so everyone would access it at the same time. Oh, okay. Code sharing. Well, I don't think I'm creating or working on one. Let's see, like when I want to share. I mean, for my code, if you're talking about like me structuring the engine, I am trying to figure out like ways to, how do you say? Like I've been trying to do more like separate branches for my GitHub so that it's a bit more like workable. I mean, the GitHub is just available to everyone. But I feel like I'm missing something from what you're saying. I'm a little slow today. Sorry. I haven't really programmed as a team, unfortunately, before. I feel like I am missing that aspect of coding. Yeah, and as far as the engine itself, I feel like I've been working on it by myself for so long. I am trying to make it where people could work on it, but it's still in such an early stage, so... Yeah, we'd love to make more progress, but it is what it is, right? Okay, I think that was it though. Yeah, specifically right now, I just got rid of Asio, so I think a lot of things won't compile right now, which is good. That's the point. And I'm going to turn a lot of these functions into like function stubs if they don't work, and then I can kind of go from there and figure out what's actually broken. Oh, I mean, if you ever want to collaborate or whatever, I'm always open. No one ever really what is the word? Like reaches out, so that would be cool. If you want to take a look at the code or you're curious about anything, I have everything available. Where is my link? So right now, as far as like organization that anyone else can see, this is basically what I have, right? So if you went to my GitHub, you can open it up. I've been working on the memory and networking branches right now. But yeah, if you're curious about like what I'm specifically dealing with, if you go to like the issues tab, I have like a bunch of issues that I'm trying to deal with. The engine's very tightly coupled right now, so yeah, there's a lot to kind of understand about it, which is unfortunate. But yeah, hopefully with the reorganization, I can modularize things and things can be better. But if you go to the project section, this basically just lays out what I'm doing. And then if you ever wanted to take a look or take a stab at something, you can ask me or whatever. Yeah, there's lots of small features, lots of little issues I need to deal with, lots of bugs to deal with. And yeah, this is basically what I'm currently working on. So yeah, that's as far as I am at with if anybody wants to help me or work on it or whatever. Do you work on any projects, Furious Elk, that are like public or whatever? But again, it's not really in a state where I feel like I'm comfortable. Like if someone wanted to help me, whatever, like I'd say talk to me first and then you could figure something out. Because yeah, it's really not at that stage yet, but I'm working on it, so. Oh, okay, I got you. Any specific domains? Are you working on games or web code? So many things you can work on, actually. I remember I did some stuff on AI. I was always confused by that because of the math. It's really unfortunate. I like math, but I feel like I've been kind of done with it recently. Okay, anyways, this is holy crap, this whole thing is broken. Disconnect, huh? Oh yeah, okay, so client UDP isn't a thing anymore, so let's just get rid of this. That would explain a lot of this. Okay. Okay, so basically, I'm going to deal with all this red stuff since Asio doesn't exist anymore. Actually, you know what? Let me rebuild this. Yeah, let me open this up again. Since I got rid of Asio as a dependency, I'll go ahead and call the build files again. Right now, the engine doesn't compile because I just ripped a bunch of stuff out. So again, right now my goal is to just get it to compile again and kind of create some very distinct function stubs that I can build off of with the new code. I don't have a Discord server. I gotta think about it. Yeah. Maybe I should add one though. Because I had a bad experience with it before, and I didn't really have any reason past that to really use it, because it's been pretty quiet. But, you know what, maybe I can start one. I'll think about it. As of right now, if you want to, like, talk to me, whatever, you can do a comment on YouTube if you want. I see all those immediately. Do I do whispers on Twitch? I don't think I do. Yeah, I'll think about the Discord. I'll think about it, yeah. Yeah. I also have a Reddit too, you could message me. I don't know, do they have private messages on Reddit? Let me BRB really quick and go check. Okay. Yeah, I checked my Reddit. You can message me on Reddit too if you have one. Feel free. Or open up an issue on the engine if you have a specific thing you want to like take a look at it or whatever. But yeah, like you said, Discord, it's like I don't have like a particular reason to at the moment. Like with the engine, I don't have like a particular thing I have in mind with the Discord, right? So. And I don't know if I want to be just moderating just to moderate, you know? So, gotta weigh my options, but nowadays I'm kind of thinking about it. So, I don't know. But yeah, I appreciate the interest, man. Like... So, are there any specific things you're dealing with your projects right now? Let me try to get rid of this UDP thing. Alliance. Ooh, I'm trying to think how I want to clear this. This is the run function. Oh yeah, I gotta think about this. What is this anyways? Resolve local TCP endpoint. To work with physics simulators or game engines. Oh, okay. Yeah. I'd say if you're interested, you should just start. It's like... I think the best time I've ever really had was those like initial few projects that I made that were just purely in OpenGL. It's a good time. I think I remember like putting together this little program that like generates a sphere, and I mean it sounds like so simple, right? But like it programmatically adds a sphere, and then like you can change the parameters and add more like make it more, what is the word, like make the resolution better and whatnot, right? And again, very, very simple, but when I put it together, and I put it together by myself and figured it out and how to like organize the data in a way where the triangles line up and everything, when it finally worked, I felt like a genius, man. Yeah, and then getting it to work with physics simulators, especially like modern ones, that's a whole thing, but it's very rewarding. Yeah, I think I still have the code for that. Okay, I can show you. Let me close up my thing real quick. Head over here. My projects, books. Wait, DaVinci. No. Personal projects. Not that one. No, I think it was in. Yeah, it was in documents. This is University 2. I know it was in my graphics class that I was taking. That class basically just taught me like basic OpenGL. Oh yeah, here it is. And then, was it this one? I always forget. Yeah, I mean, but believe me, man. I mean, it that feeling doesn't go away. you just keep feeling dumb at like a different situation, or at least that's just me. But it's still a good time, regardless. Okay, there we go. So yeah, I remember this was my first little renderer, and then I had I forget where the settings are. It's all global variables, you know, bad practice and everything, but you can change some of the variables and make these things like more or less like precise. Is that the word? I don't know. Add and remove vertices. That's what I meant. There we go. Oh yeah, it was right here, wasn't it? Yeah, it had this thing called model accuracy, and you could do like 20. But yeah, I felt like the moment where I realized I could like manipulate the vertices and change them at runtime just felt like a big like aha moment for me. So yeah, so yeah, you can see they're kind of like less precise. I can't think of the word right now, but yeah, let me let's do 4. I think it fails at like 3 or 4 or something like that. And of course, in good fashion, I have a ton of errors. Yeah, see, this is like the simplified version. I think for like modern spheres, like if you're doing like a planet, they usually do like icospheres. So they kind of break them up into like icosahedrons. That gives you like a consistent spacing. This gives you kind of similar to when you look at a globe. At that top bit, that's kind of how it ends up looking. So this is kind of a similar algorithm. But yeah, it's a good time. I have a bunch of other random projects, but I haven't looked at this in forever. But yeah, I would say if you do plan on starting, I would say just do it, you know? You can go to Learn OpenGL. I'm still trying to finish this website too, so there's a lot of high-level stuff you can get working with this website, so. But at the beginning, it teaches you everything, so. And then from there, you can start worrying about more like different graphics APIs and everything, but yeah, I feel like it's just satisfying getting something on the screen. I'm trying to think what I want to do with this. Okay, so if I, like I want to keep the logic, I think. Connect to server. With a server IP and a server port, yeah? Because I already have this in the networking too. I have a variant of the client, and it has a init and terminate. And yeah. Maybe I'll read through this and see what needs to stay. I don't know. It was shown that. Yeah, don't worry about it, man. I'm mostly chilling on these streams. But yeah, I hope you have a good night, a good afternoon. Good luck with your projects and everything. is the busy timer, isn't it? Send multiple UDP connection checks to ensure disconnect from server. Okay, yeah, I'm definitely gonna turn these into function stubs. I was wondering. I guess it starts here, right? I don't know. There's so much code, so I'm trying to think of like where's the good place to start. No, you know what? Let's just make a compile. So use this error code. We'll read through it and get rid of the error codes. Use this, create TCP socket for new connection. So basically this just connects to the server, right? It takes the server IP, it takes a server port, whether it's a remote, whatever, yada yada. And then it connects, right? That's the whole goal. So as long as we do that, we should be fine. This part gets the error code, create TCP socket. Yeah, this has nothing to do with me. And get rid of that. Now we're looking for resolve host port into a TCP endpoint list for the server. Yeah, I don't care about any of this. Let's go ahead and get rid of it. Maybe I will put a to-do for maybe resolve the local IP. I think we already do that, but I don't think I store it. That might be the difference. Initialize connection to remote. Yeah, it's just a TCP connection. Attempt UDP connection. Create connection object. Start reading messages. Okay, yeah. So maybe I'll put a note. Start UDP connection. Connection. And here is where we add these are the UDP keep alive packets that I send. But I don't think I need this anymore. I already have my own way of establishing a connection. So yeah, I think this bit is not needed. And then this is what happens at the end. Okay, so this one, basically this all closes up with submitting this little update thing. So we know that the connection was successful. And then waking up the thread. I don't know if this is sending a message or something. No, I don't think it is. I think only this sends a message. Okay, so I think I'll just resolve this all down to send message if failure to connect. There we go. All right, disconnect from server. Probably still want this. Do I want to make a Discord? Okay. Wait, no, actually, I don't know. I'll think about it. Let me write it down so I stop thinking about it. No. I will think about it later. All right, disconnect from server. So this one, I believe, resolves just the TCP connection. It's not really a connection anyways. I guess so, yeah. All right, so yeah. Close. Okay, and then here we have the network context, Asio context, yeah. An Asio thread and then the TCP connection reset. Yeah, this all boils down to basically close local Asio threads. No. Network/event threads. Yeah. Yeah, just query to do, query connected status. And actually, I have an enum for this, so even better. But I'll come back to this. Oh, gotta be careful with this though. Return false for now, since there's no connection. Resolve local TCP endpoints. I think this was just a helper function. Yeah, we don't need this. Let's go up. Okay, it's connected. What about this? What is this? Ooh, okay, so this one's gonna be a bit different. We have these message queues that we're doing, so sleep the network thread if there is no messages to process. Yeah, I guess that's a good point. Yeah, I already have a way of doing this, but I should still put some comments. So this first one is actually just leave the comment, yeah. Process message until queue is empty. I don't think I have this max count functionality set up yet, but it's pretty easy to add. But basically we just open the message, which is just the switch statement, I believe. And then continue, yep. Okay. Send TCP to server. Yeah, this just is not a thing anymore, so let's get rid of that. Yeah, no longer a thing. What's wrong? Oh, we don't have a K max message count anymore. Huh. When did that happen? Yeah. So send UDP to server. I suppose that's fair enough, yeah. Yeah, okay, so to do, send the message. And for now, we'll take this. So let's find all send TCP to server and just place it with send UDP. Just get rid of those errors, I guess. All right, I think I do want to preserve the structure of these, though. Yeah, I will preserve these. Yeah, you know what? These are perfect, actually. So I'll leave them alone. They're going to need to get processed differently once I fully refactor everything, but as of right now, this is fine. This preserves all the functionality. Okay, the submit to event queue is kind of interesting, though. I gotta see what's up with that. But yeah, otherwise, looks like it's good. Looks good. Open UDP init. MUDP connection successful. Okay, I should put a to-do here. To-do indicate. I don't think this is necessary anymore. They're necessary anymore, yeah. Oh yeah, just give me a sec. Okay, I am back. Let's see. I think at some point I am going to get rid of all these unreferenced parameters and just do this. Something like that. We'll see. Alright, anyways. Okay, here's the client service. Okay, so... Cool, I can kind of clean this up. What's up with all these? And this process event queue needs to get cleaned up. Certainly. Okay, we'll read through it. Let's see. Where was I at? Run, terminate, init. Okay. So, we create a client, which, to be honest, we do, but... Yeah, let's do that. To do, get rid of this. I don't want to be doing that explicitly. It's kind of weird. Yeah. I'll leave this. This is fine. And run. Yeah, you know, I don't want to do it like this. Let's just do a to do. Well, do I? Actually, you know what? Let's leave it. Wait for network threads to stop, so we'll just do what to do. Okay. Okay, and then this run thread is very interesting. I'm wondering how I want to handle this one. Okay. Ooh, okay, so the UDP thing doesn't need to be here anymore. I know that for a fact because that's... I mean, our connection is just UDP, so I don't really care. Disconnect from server, huh? What does this do? I guess I can leave that. Yeah, these are fair enough. Start connection to server. So here we do client connect to server. And then we provide the server IP along with the server port. That doesn't change. Yeah. So these are fine. What is this though? Oh, just a, yeah. Okay, sure. Ensure the connection is started. Yeah, fair enough. Quit thread though. Yeah, this is the client, which holds its own network thread. This is the thread that gets started, isn't it? And then we get stuck in here. Yeah, that's fine. Yeah. Okay. I'm wondering if I want to erase this code or if I just want to leave it. Okay, well the UDP I'm gonna get rid of, definitely, because that's not needed anymore, because all we are is UDP. Yeah, and then this thing. Okay, you know what? Let's do to do. And I'm gonna put to do here. Run the network thread. There we go. This is such a nice API, to be honest. I don't know why there's a magic number here, but sure. It's not the worst magic number ever. Okay. Yeah, just run the network thread. Or maybe even... I might want to keep this as a reference. I'll do if 0. And just collapse this code. Because I still want to look at it. But yeah, just run network thread. That's basically what we need to do there. And then disconnect from server if needed, and then whatever. So end run. And then we'll say, yeah, this one. Go here. And then wake up notes. Yeah. To do wake up network threads so that it doesn't close. That's fair enough. Okay, and then session slot, sure. Sends an event, sure. Send all entity physics, yeah, sure. Enable ready check, yep. Session ready check, yep. These are entirely fine. All these do is just submit events to the network thread queue, and then it can handle it. So these are entirely fine. Only thing is it creates these objects, but whatever. I never said this was perfect anyways, but no reason to mess it up right now. Okay, and this is how we handle the function queue. This is how we handle the network queue. There's all the on events, sure. It just routes it to the appropriate event handler. We handle the events inside the actual client, yada 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 yada. So that's fine. On enable. That's the one thing with these service functions, service classes too, is you have to route things through them. And you end up with like duplicate function definitions. Okay, then here, this I'm going to get rid of. But just because I'm replacing it with something else. But not right now. Okay, that's fine. Okay, I think this is good. Let's go check address really quick. Or network common. How you doing? these are kind of garbage, aren't they? Should I keep them? I don't know. Network thread, network sleep, huh? Network thread, network sleep. I don't think these are necessary anymore. And as much as I like this payload code, I don't think I want it. Yeah, because a lot of these types are unnecessary now. Yeah, okay, I'm gonna get rid of all this. Because this is using a lot of old assumptions. So we don't do this anymore. There's no need for an Asio context anymore. There's no need for an Asio thread. Basically, all of this is garbage. Yeah? Ooh, okay. The one thing is, I do like the way they put the messages. What is the message anyways? It's this. No, I'm getting rid of it. I'm getting rid of it. Because a lot of this uses Asio. Again, I already have my own way of doing this, so I'm not gonna preserve that just for nostalgia. This whole message thing can go away. The message header can go away as well. No server TCP connection. Value limits. No config is still valuable. That's fair enough, yeah. These are still relevant. Asio API can go away. Okay, cool. Config file can stay. There's no reason to change this. I'll come back to this in a second. What's up with this? Okay, so this one's interesting. I don't need any of the sync code here anymore. So what's up with this though? Oh, there's sure, yeah. I don't know. Yeah, because it uses messages directly in here, which also I don't like. Okay. I think for now, yeah, you know what? Let's just ignore all this, because this session code is assuming a lot. And I think the way that I'm going to do this later, I'm going to rip out a lot of this code, because a lot of it's just straight up not necessary. And then also some of the assumptions that it makes is based on the way that I identify connections using the server TCP connection struct or whatever. And I have a different way of handling that in the new code. So I'm just going to go ahead and get rid of this, or just not worry about it right now. And for now, we'll just go ahead and return K invalid. I think I still have that, yeah. Session doesn't seem right, but whatever. Return K invalid. I guess I have a little break I should take. All right, I'll be right back. Okay. I am back. Back to some refactoring. Alright, but yeah, let's go ahead and check. Yeah, as I look through this code though, it's I don't love it. Use a lot of old code style, and yeah, frankly I just don't like it. What I really need is just some time thinking of improvements that the code needs, and then just do that. And then just, you know, kind of break it down to like, what are the real bits that need to be fixed, and just do it throughout the code base and see how that improves the code. But I'd also like to just get this done. Would be nice too. This whole networking thing, so I don't know, man. Okay. If it's been a few days since I've sat down and worked on this code base for a decent chunk of time too, so this is very nice. Very, very nice. If 0 Okay, there we go. So basically the session code is now garbage. Which is fine. Okay, this doesn't know what this is. Okay, I'll just put a definition up top. Oh, we do have this. Okay, so server TCP connection. Yeah, that's fine, I guess. Well, again, we'll come back to this. So, I don't even want to look at it, to be honest. Okay, let's deal with this client code really quick. I know I broke a million things. So what is it here? So these just get routed through. Check messages from server. Oh, okay, yeah. So that's what that does, and then this sends it. Sure. Wondering if I should just call these function stubs and call it a day. Yeah, because I'm going to need a separate API for putting this together. Oh yeah, there's no more network context. Right about that. Okay. I think I know what I'm going to do. So let's go over to network comm, and we're going to make the message thing again, but it's just going to be temporary. So we're going to call it struct message. And there's nothing in there. It's just an empty message. Oh, okay. Maybe I should define it with something. Float. Okay. I should put a note here. Remove this, please. Okay. Message is undefined. Why is it undefined? Why is it supposed to be a class or something? Oh, do we not have... Oh, okay. Okay, sure. Now I know there's no overloads for these things, so it's gonna throw a bunch of errors at me. Yep. That's what I expected. Hash if 0. Hash end if. Okay, how many times do I have to do this? Let's see. Looks like it's going to be quite a few times. You know what? Let's just make the operator overload do something. And again, every time I have to do an operator overload, I always forget how to do it. Let's go find out. C++ operator overload. Let's just find an example. You know, I'm too lazy. Let's just get ChatGPT to figure it out for me. It's not like I'm going to use this anyways. Can you give me operator? A templated operator reload. Symbols. A struct message. Struct message with any type. Oh, it's trying to actually do things. That's kind of funny. All right. Sure. Why not? Okay, does this have to be a friend? Oh, the whole thing's a template type name T. Okay. Now, can I just do template type name T? I mean, messages in a thing. There we go. Don't know if this will compile. We'll see. Don't really care, to be honest. I just wanted to stop throwing errors at me. Okay, this is actually doing something. I don't want to do anything, just... This just irks me every time I see it. Okay, there we go. Yeah, don't do anything. Just overload the function. Oh yeah, there's a header. Okay. Append payload. Oh yeah, I had a header and then... Okay, sure. Probably should just get the original definition, huh? Well, whatever. What is it called? Message type. Type header. Okay. And then what was it? What was that called? Append payload. Something like this. Looks like it takes a void pointer and a size. T. That's fine. Doesn't look like it has any side effects. Void pointer data size T size do nothing, please. What is wrong? Okay. It's doing so many things. M header message type, okay. Ooh. Alright. Oh, okay. Drink my coffee too fast. Let's just go find that original code I had and put it back. Ooh, okay. Drank my coffee a little too fast. Okay. I think it was network common. Okay, yeah, here we go. Cool. All right, let's go ahead and put this back. Yeah, I'm working on a... I'm gonna go ahead and call you Headman. Oh my. But yeah, welcome. I am working on an engine, or a game engine. Specifically, I'm just refactoring some networking code at the moment. Or integrating some networking code that I was already working on into the engine. And yeah, it's pretty much what I'm working on. Sorry, I'm I was just choking on some coffee, so I'm a little out of breath. Oh, for sure. Yeah. I mean, you do you, man. Ooh. But yeah, if you have any questions or anything, just let me know. Right now, basically, I don't know if you're aware of like the Asio library for C++, but it lets you do like cross-platform networking. I'm getting rid of that library. I'm using POSIX functions instead. So basically, I'm just ripping out the original stuff, original library that I was using. Oh, Wara. Gotcha. Did I say that right? Wara? I'm assuming with the umlaut characters, it might be pronounced differently. Ooh. Get payload. Oh, okay, I remember what I was doing. Yeah, so I was grabbing just some temporary code that I had prior and putting it back into my code just so it compiles. Let's see. Maybe I can show you the engine real quick. If you're curious about the engine at all, I do have links in... Are they in this description? If you go in the description, you should see a link to the engine, and you can take a look at the README if you're curious about anything. Otherwise, if you have any questions, just let me know. Yeah. If you want to see me use the engine, let me know. I'm just, right now it's not really in a building state, because I'm kind of ripping through some code, so. What was I? Okay. I think I remember now. So we're going to replace this with this. And yeah, this thing, we're just going to implement the actual code to do nothing. This should return, what is this? Return message, I think. That should work. I don't want this code to do anything. I'm just trying to get it to stop yelling at me. As well said, I don't know how to pronounce it. I'm from Argentina, but I am of Polish descent. Oh, I got you. Well, it's an interesting name. Yeah, I've seen those characters before. I studied German when I was in college, a bit. But I know that umlaut is kind of generally used in Europe. That's as far as my understanding goes with that. Yeah, me, I'm, what is it? What is it? I'm half German, so yeah. That's kind of where that came from. Let's return nothing. How is Argentina, by the way? It's a very big country. Okay, I think I'm good. All right, so right now I'm trying to make sure this compiles. Okay, this looks good again. Let me see what's up with this though. Oh yeah, this isn't a thing anymore. Wait, what is this? Oh, okay. So this is just submitting a function for the network thread to handle. We have this little mutex that pops up for it. Don't really love this API to begin with, but yeah, here we just want to alert the thread that we're doing something, and we can get rid of this. "90% of the population is descent of Europeans." Okay, I got you. So let me take a look. I don't know the full history of that area, but I know let's see. Yeah, it's a big country. Oh, I'm sorry, that was my ignorance. I confused Argentina and Brazil, but Brazil is huge too. Is the landscape nice there, though? It looks like it can get pretty. And the southern extent goes all the way down to close to Antarctica. I've always heard of those salt flats that go along in Chile, but I don't know about Argentina. Okay. Let's see. That's very pretty. Where is this on the map? Let's see. Oh, it's right next to Uruguay. Okay. Really, this whole area, like, it's 90% European? That's interesting. I'm assuming that has, like, weird historical context. Yeah, colonization's kind of crazy. No, it's beautiful though. Oh, I got you. Yeah. Okay. Okay. Well, what is it? Do you work on any code yourself? I've seen a lot of like South American channels popping up, specifically working on like game engines too. It's really cool to see. I should put a note here. Okay, this one's good. All right, I believe the last bit of code that needs to be cleaned up is over here. So we're gonna get rid of this. And I believe this entire backside is just full of red. Yeah, lots of things that won't compile, so we'll figure it out. Cybersecurity. That's an interesting field. I never know how to properly get into that. Are you studying at university, or are you kind of learning on your own right now? I have a CompTIA Security Plus certification, but I feel like even after I finished it, I don't feel like I really know a lot, if you know what I'm saying. I feel like I need to get more experience with like CTFs and kind of breaking into like actual code and figuring out how like malware works and everything. But I know there's like tons of directions you can take that, so I'm always a little confused by that. Wait, what is this not? Oh, it doesn't know what a server TCP connection is. I see. Yeah, fair enough. Yeah, because it needs to be aware of the connection that it's sending the message to. That would only make sense, right? So this server TCP connection doesn't exist anymore. I already kind of zapped it. So since that's the case, I don't know what I should replace it with. Because, okay, basically where I'm at right now is this network code. Again, it used the original Asio library, right? This network 2 is my new code. I've already sort of built this code up myself in a separate repository. And it uses its own way of identifying individual clients. So I don't know. I'm just trying to get it to compile right now. I don't want to integrate all the code immediately. Okay, well, it looks like we have a get ID here. that's mostly what we do here. We just get the ID of that client. So I suppose I could just make like a dummy function for now. Or a dummy class of the server TCP connection. Not the best solution, but again, I just wanted to compile. And then I can go from there. Server class, server TCP connection. Oh, you know what? Let's put this in a header somewhere. We'll put it with that big chunk of code I was messing with just now. Here it is. Okay. And the main thing is it has a get ID, I think, which is it returns something. Size T? What was the size of it? This takes a what? Wait, what? Connection pointer. Yeah, this passes the actual client along. Get ID. Yeah, I don't have any type distinction here, do I? I'm pretty sure it's a uint32t. So we'll just do that. Okay, sorry if I'm jumping all over the place. I'm just trying to get this done. uint32t. I think it's what we return. And then get ID. And then we'll just return k invalid session. Not a session, we'll just do 0. It's supposed to be a dummy function anyways. You're traveling and don't have a... Oh no, it's all good. I'm just working on the code, but... I think I was just talking about cybersecurity in general. But yeah, or my lack of experience with it, so. It's missing int. What? Wait, what? Maybe it doesn't know what... Wait, hold on. What? Explicit type is missing. What am I doing wrong? Is it just the linter doesn't like me right now? I think that's the case. Okay, it's kind of annoying. Let's do private uint32_t data return data. No, that's obviously not the issue. Something wrong with this. We made const. Yeah, I know. We just made const, sure. But explicit type is missing. What? Okay, I'm just gonna chalk that up to this thing is just not agreeing with me right now. That's fine. This is back to the server. Okay, it seems like it recognizes the function though. I think we're good. Alright, let's head back up to the top. So when we initialize the server, we provide a port for it. That makes sense. And then here we're initializing a TCP acceptor. No. Yeah, just no. Is that here? That was like a previous way I handled that. So yeah, no, we're not doing this. Basically all I want is... What? Oh. Okay. I'll put it to do here. Initial lies the server context, maybe? I don't know, I gotta read the rest of the code and see what happens. Okay, but here we start the UDP server. This is no longer a thing. So the previous Asio connection used both a TCP connection and a UDP connection, which is bad. So now the new code just uses UDP. That's it. So all of this distinctions where I'm doing TCP and UDP is going to get thrown out. One thing I probably do want to do is store this port though. I don't know where I'm storing it, but store the ports. Because I should be using that. But yeah, this is garbage now. Client async connect, that's not a thing anymore. Yeah, this is all a bunch of functions that were necessary because of the way Asio works, is you need to prime it with work and then it starts running the separate thread. But in my case, I have more of a very specific way that I build up the threads, so I don't need this anymore. So we're gonna get rid of this. I'm just gonna put a comment where I want to replace the code. Okay, this is gonna be similar. So this Asio thread, right? This responds to messages that are incoming from external sources, right? So if a message is received on a port, right? Or not port, a socket, that's what I meant. If it's received on the socket, this thread will pick up that information and then let me know that I should process something, right? It also does a bunch of other jobs, and in this case for the server, I think it checks for new connections, it reads messages, and I think it does a third thing. I forgot what the third thing was. But yeah, again, its main focus is respond to things happening and do it in a very like efficient way. Yeah. So I have a separate thread that already does this on my other networking situation with the POSIX functions. So I don't need to worry about that, but I should still put a note saying we do want to start. And I want to say instead of network thread, start event thread. Or just the event thread, I guess. Network dash event. The network thread should be running, and then we start it. Okay, sure. Clean up dead connections. Okay, so here is the main section where we process messages. The main focus is just to send it off to this function, which checks for message types. Don't know if I love this switch statement, but yeah. What's going on, Dragonif? You got the ick. You're like, ugh, C++. Yeah, I mean, yeah, nowadays there's a lot more languages you can use, right? Let's see. But yeah, welcome to the stream. Thanks for coming by. Are you a Rust person or a Zig person? I guess Zig you can be a little unsafe with, right? If you want to be, right? Let's see. All right. I do need to remember to do this though. Allow the server main thread to sleep when no work is provided. Oh, is this where I do that? I always forget that. And then here we process all the messages. Why are we sleeping here? Oh yeah, this is how I did. Okay, I remember now. You were born under the crab. I see. a true rustman. I mean, yeah, I guess so. Yeah, I have seen a lot of conversations surrounding Rust and whatnot for memory safety, and I think the recent like CPP con had a lot of people talking about Rust too. Well, I mean, that's fair enough. Yeah, I'm a little in deep with this code though, but I was kind of looking at Rust for a little bit. I have been seeing some of the people that come in who kind of work on their own little engines and whatnot. I think at least 2 of them were working on it in Rust. One of them was using WebGL, I think. Yeah, this guy. Shy Assassin, he's really cool. This is on Twitch though. But I think he's using WebGL and yeah, I think WebGL, and he does his own interactions with the OS, I think. I forget how that works. I remember he was explaining it to me. I hope he keeps going though. Allow the server main thread to sleep when no work is provided. Okay, so yeah, basically this. I'm gonna get rid of this. Basically right now, what I'm working on is I used to use Asio for my networking code. And basically this is me ripping out Asio and I'm switching over to like POSIX functions. Yeah, so I ripped out Asio and right now I'm just making sure everything compiles. So yeah, we have a place where we sleep the thread. I don't know if that really should exist right here, to be honest. I'll see. I do want to preserve this though. I like having this max count thing for the messages. Maybe I could store it differently though. Handle. But yeah, if anyone has any questions, just let me know. Let's see. Okay. Actually, do I want to keep these? Let's see. So we have this switch statement, which I do not love. Someone was suggesting like a factory structure for like putting together these packets, so I can do like more of like a encapsulation, de-encapsulation type of deal, instead of having like this flat structure. I gotta see. Because this is a little annoying to have to upkeep. Okay, but here we submit messages. These are fine. Yeah, this is session code. I don't want to mess with the session code too much. So that's fine. This one, what the hell is going on here? All client connections. Oh, it must have been over here, huh? Okay. I'll come back to this, but for now I don't want to deal with that. again, I'm just trying to get it to compile, then I'll start cleaning this stuff up more specifically. Check connections valid. So we just loop through all the connections. Yeah, this is going to be very different. And we implement a lot of the logic directly in here, which I don't know if I love that. But I might want to keep this around just to know. So I think... Okay, what's going on? Basically, we're just looping through all the clients, and then if the conditions are set where this client should disconnect, we're going to go ahead and disconnect it from the actual connection. And then now we need to manage the actual memory inside of this vector, so we're going to go ahead and set it up to be erased. And then, you know, sets this boolean to be true, whether any client needs to be erased. And if true, we'll just go ahead and call erase here. But TLDR, I mean, remove client connection if set be this. Remove client connection ref from. Remove client connection ref from. What is it called? Remove client connection ref from data structure. That's what we're doing. And yeah, you know what? Let's go ahead and if zero this, because I still want to look at it later, just in case. Again, I already have my other. I already have a method for checking this, anyways, but I still might want to be considerate of what I do here. No more TCP messages. This is just gone. Okay, wait. Just give me a second. I always get this message on my stream thing. Oh. Oh yeah, I got a message. Gotta go. Happy coding to you, kitty cat. Hey, appreciate it. Presumably you too. But yeah, I hope you have a good rest of your day or night. Oh, thanks for coming by the way. Okay, I'm just gonna do something really quick. Fix up this. Event thing really quick. Actions. And stream. Okay. Hey, I'll change that later. It's fine. Let me just put a note for myself. I'll be right back. Okay. Sorry if I'm mumbling. I'm just trying to... I have like a little message thing that pops up when the stream should end, and I usually have it set for 3 hours, but nowadays I'd be doing it for 5 hours, so I gotta remember to change that. So, send TCP message to all, yeah? Let's change that. Let's see. Okay, so this is all whatever. The main thing is to do identify / validate the clients and send the message. That's all we're doing here. Okay, wait, I'll be right back. I'm getting a call. Okay, I am back. I should have add one of those like progress bars that some of them streamers have. That'd be really nice. Or those like to-do lists with the little color effects on the sides. That'd be kind of fun. I always see those and I get kind of jealous. All right, but I'm back. Let's see, just yapping like I do. I had to take a call real quick. All right. So yeah, I'm still just trying to get this to compile because I ripped out Asio. No more Asio. So yeah, let's see. This is the final file. So if we can get rid of this red, then I can see if any other compile errors pop up. For client and all client connections. Okay, so this is a UDP message all, even though it's a server TCP connection. Sure. UDP message to all clients other than the ignored client. Okay, and then we're gonna get rid of this because this is just a function stub right now. Okay, send a message. So, oh yeah, let's go through all these. Find send TCP and replace it with send. Okay. UDP. There we go. What's wrong? Oh yeah, it doesn't have a it doesn't have an overload, does it? Okay, sure. Let's go to the actual type. We'll say, again, these are all just random function steps. I'm not actually building this up. I'm just trying to make sure it compiles. So it's a void send. What was it? Send UDP message. Then we take in, I think, a ID. Oh, just the message. Okay, so message reference message. Yeah, just do nothing with it. Oh wait, no, this is it's an empty statement. Okay, good. Let me still read these though. Oh, where's my coffee? All right, send client left message to all. Again, this is like a specific message I'm responding to. So I'm gonna leave this alone because I still want the majority of this functionality for the moment. Ping is fine, even though I don't really have ping pong messages. Yep, deny, approve, updates. Yeah. Okay, these are good. I'm gonna leave these alone. Okay, stop server. There we go. This is what I want. So okay. I just thought of something. I'm gonna take a look at it later, but for now, let me just write it on my whiteboard really quick. Okay, I'm back. Close every TCP connection. I'll put that as to do. That's fair enough. Close Asio context as thread, so I'd say not Asio context, but close / network event thread. And join this thread, I suppose that's fine. Okay, this is the objects. I'll think about this. Question mark? Okay, again, all this Asio stuff is garbage, so we'll get rid of it. This is the starting the UDP server, which, I mean, I believe this is just entirely unnecessary. Yeah, this is just unnecessary. Because we don't have a separate UDP connection now. It's all wrapped into one. Session clock, this one's still valid even though I don't think it belongs here, but I'll come back to that. Start session. Yeah, that's fine too. Gotta stop using this, I'm gonna put the comments instead. I wonder if I surround it and then do... No, okay, never mind, I thought that would work. Okay, what am I doing here? Client connect, client. Okay, so on client connect. Yeah, this one's fair enough. I should probably keep this. Let the new client know it has been connected to, and then update the client count for all of the clients. Yeah, fair enough. Yeah, okay. I don't disagree with these actually. The only thing I would say is still sort of ref. Yeah, I disagree with this very heavily. Wait, what? On client connect. Wait, what is going on with this? Client count. Why are we passing the client count? Oh, okay, yeah. No, I got it. So to do get the current size of the client array. Okay. And then for now, we're just gonna return 0. I have a way of handling this, so it's fine. Send client updates. These are still valid as far as I can tell. Wait for client connection async, huh? Yeah, I kind of disagree with this one. I'll say to do. Just put 0 here. To do current client count. Okay, contains, you want to remove client from the session. Yeah, let's not mess with that. Yep, manage session, sure. Okay, that's garbage. Terminate, sure. You put a note for this one. Okay, we're almost done. So wait for client connection async. Honestly, I want to just remove this entirely. Yeah, this doesn't need to be called at all. I'm sure I call it somewhere else in the code, right? Okay. It was probably in some previous code in the something I deleted, so that's fine. Probably intentional anyways. Yeah, start server, that's fair enough. Let's see. This doesn't do anything. Terminate. Sure. Here we just close the server and then close the server. Or check if there is a valid pointer. If not, stop server, which doesn't do anything. Reset just the shared pointer, sure. Kind of disagree with this, but I'll come back to it. Check for messages, process. Okay, so here's the ren function. Yeah, that's fine. We'll do a to-do here and get rid of this. Okay. I think we're good. I think that's it. Just checking for any more errors. All right, next thing, let's just get it to compile. Hopefully I didn't expose anything in the outside code. I don't think I did. So, well, we'll see right now, I guess. But all the outside API should still be exactly the same. Okay. All right, I think we'll get some water real quick. I'll go ahead and let it compile for a second. Okay, I am back. What did I... Oh, okay, sure. Let me make sure I didn't break something randomly. No, that looks fine, I think. Yeah, looks good, looks good. Looks good. Okay, yeah, somehow I just deleted that. I don't know how that happened, but sure. Okay, so something failed. I think it was just because of that that extra brace. So let's try it again. Or lack thereof a brace. Okay. I don't think I call the networking code anywhere. So it should be fine. I think. Yeah, that's good. All right. No, I believe this is gonna break. Yeah. Because we didn't initialize anything. Let's just continue. Yeah, fair enough. Yeah, I mean, nothing got opened or closed because I didn't open or close it, so that should be fine. Okay, sure. Looks good to me. All right, it is compiling. That is a pretty big step. Let's just let's take our wins where we get it. Oh yeah, I got rid of a lot. I got rid of Asio. Yeah, no more Asio, which is good. Less dependencies. Usually better, right? Okay. Okay. Remove Asio files from dependencies. Dependencies. Remove Asio references in premic files. Which again, probably should use cmake, but whatever. Yep. Remove all Asio code from network. Kargono source network folder. It's a pretty big commit, so let that go for a second. There we go. Okay. Good. Still compiles, so that's a good sign. Oh, Suki Levante, how's it going? I probably butchered her name, sorry. But hey, how's it going? Nice to see you. Wait, you... Wait, have you been here before? I feel like I recognize her name. I stream pretty infrequently, so I kind of forget. Oh, you never did. Okay, you have a similar name to someone else then. But yeah, I'm doing good. Yeah, thanks for the follow, by the way. Appreciate that. I don't know if I earned the follow or not, but yeah, right now I am working on integrating my new networking code. I don't know how familiar you are with like Asio or like POSIX networking sockets and whatnot. But right now I'm basically replacing the Asio library with what is it? Just using like BSD sockets. Oh, okay. Well, yeah. Let me show you. I just got it to compile, so I'm kind of happy about that. So maybe I can show you the engine. If you're curious about anything else, you're on Twitch. I do have a link to my YouTube, so if you want to take a look at anything, I have everything on there. And I have a link to the engine. It's on GitHub. So if you're curious, I have a README. It's all right. It just tells you how to build it. But yeah, this is basically the engine. Yeah, if you have any questions, just let me know. This is C++ though, by the way. So yeah, I think someone came in here earlier and was like, C++? What about Rust? And I feel it. Or he was saying C++ is unsafe for memory, which isn't wrong. But yeah, I don't know. I love my C++. Yeah, and I mean, it's a superset on C, right? So if you want to write C code in C++, you can just do that, right? If you feel like it. I do use the C features sometimes, so. So yeah, I mean, I can kind of show you specifically. So again, like, if you look over here, I have this like network folder. This was originally using Asio. And I have this network 2 folder. It's very temporary, but in here is a bunch of like POSIX functions. So if I go to, I think it's socket. Yeah, here's the actual like BSD sockets. So you initialize, this is just for Windows here. And then where do I actually receive? I think it's here. This is receive from. This is like a POSIX function for receiving packets. And then send to is another POSIX function for sending packets. And my protocol is just using UDP. So yeah, I'm just trying to get this integrated at the moment. Coding in Rust right now. Yeah, I don't want to start a C++ Rust war. I don't have a strong opinion about it. It's fine. But yeah, Gandev, do your thing. Yeah, I looked at music video from a song that I listened to a lot because I noticed that it had one. It wasn't what I expected. At least I know now. Oh, you were looking into that just now? Okay, okay. The song was just stuck in your head or something? Let's see. All right, so at the moment, right, I got it to compile. That was like my main goal, I suppose. So the next thing is to start actually integrating the code, right? I'm just trying to think of where I want to start with that, because that's kind of a big statement. So the main thing is I have this static client service thing, and I just want to make sure that everything here that gets called still works, right? So the back end can be implemented however it needs to be. And then as long as these functions still work, externally to the rest of the code, it should be fine. Let's see. Oh, one thing I wanted to do though is I have this code kind of just sitting here. I want to wrap this into its own little section for a function queue and an event queue. Yeah, I want these to be like their own little thing, so I think that's the first thing I'm going to do. Let's see. At least I think I know which city it was recorded in. It's hard to get it away. It is sketchy. They managed to make the video look like it was, but it was released 1 year ago. Yeah, I feel like I see a lot of the nostalgia popping back in with those, with music nowadays, right? What do they say? Art is circular, right? Every 20 years or something for fashion, right? I always forget where I heard that saying, but right, but they've been releasing recently. Oh, sure. Okay, really quick. I'm gonna replace this. So I have something for this. I just need to find where I put it. I think it's called event queue file. Here it is. Oh yeah. Got a little link for this. So yeah, I already have a class that basically takes care of the event queue. And all you do is just provide an init for the callback. So this is what gets called when you want to actually process the event, right? And then you submit an event. It takes in a mutex to make sure you don't get any weird multi-threading issues. Because the idea behind this class, or behind this whole thing, is that it contains this queue of events, right? And then it gets handled by this single function, and the mutex just makes sure that you don't have any issues. And this is supposed to be stored on a thread. So if you have a single thread, it has all of its data and it takes care of itself. And then you have these specific points where the threads interact with each other, and that's either an event queue or a function queue. And you got to make sure that those don't step on each other's toes, if that makes sense. So that's where this comes in. Singer that was active from 1995 to 2024. Oh, show. 1995. Yeah, that's like my entire age, isn't it? What was the band? Or not the band, the singer. Oh, well, no, you said members, so it's a band, yeah. All right, let's see if I can replace this. So let's go ahead and use this event queue. Don't know if it's gonna work though. Also, I'm not sure if this should even exist here. Now that I think about it, I feel like the event queue should be internal, maybe? Let's see. Yeah, you know what? All right. Real quick, let me get this thing working. So we're gonna erase. This is the client side, right? So let's just go ahead and erase this. I'm just gonna focus in real quick. So we're gonna include the event queue here. Kargono events event queue. Okay. And then right here we got rid of this. Okay, so we do events event queue and event queue. Okay. And now we'll get rid of this and go ahead and use this. The only thing is we need to integrate this event queue. So we need to make sure that when we initialize the client service, that we initialize the event queue as well. Or something like that. I don't know. Releasing a 7-minute song before dying. The band is Les Cowboys. Okay, yeah, I'll take a look. Let's see. I have a separate audio from the stream, so I can listen to it, but you guys are not going to hear it, which is kind of good for my DMCA. But I will listen to it in the background. Is it these guys? I hear my cat. Let me let her in real quick. You okay? Come over here. Oh my god. Calm down. Alright. Any songs in particular you recommend? La Fin du Show? Okay. Okay. It wouldn't pop up. Let me up my YouTube. La Fin du Show. Alright. Seven-minute song before dying. La Fin du Show. I got you. Turn down just a little bit. I'm not going to say much for a little bit. I'm going to go ahead and listen. It's hard for me to focus while I listen to music with words in it, so I'm going to be quiet for a bit. Let's see. Okay, so let's replace this event queue thing. Okay, so here's where we submit to the network event queue, right? So we already deal with this whole mutex thing. We don't need to worry about it. The only thing is this checks for a valid client, which arguably I would agree with, so I'll leave it alone. Yeah, no, it must suck to lose a member that you played with for so many years. I feel it in the music. Okay. So we're gonna do S client. I don't know if I expose it or anything. S client. S client. Yeah, you got your frontliner too. Yeah, that sucks. Yeah, it kind of reminds me of what is it? The Linkin Park, the one who passed away. But of course, his was more sudden. These guys, of course, they know, right, that he's passing away. He's there to talk about it. Submit event. Okay, so we're gonna do E, right? Okay, I think it's good. Just like that. And we submit it. Okay, cool. And then we go down here, and then we're gonna say, so we don't need to do any of this. The only thing I would say is we still want to check if the client is, do we? Arguably this whole client service thing is kind of meh in the first place. Let's see. Oktoberfest. Yeah, and then if they got canceled, then no, it makes sense. Yeah. Okay, so I think here, process the event queue. We're going to say S client, M event queue, process queue. That's it. And the only thing is here, when we process the thing, we're calling this function on event, right? So let's grab this. This will call that function right here, process. So we need to provide it with that context. Okay, wait, let me find this thing real quick. So I believe it's going to be in the init function. We will create the client, so we'll say S client is equal to create ref client. Yep, it's default. And then we'll say, should I do in the initialization function? Is there one for clients? There is not. To do. Should I make a separate function for initializing? Sorry, I'm just really trying to think about this. I don't like putting things in constructors if I can help it. Trying to figure out. Yeah, it's in French, right? I don't understand the language, but I feel it though. That was nice. You said it was 70 million. Less cowboys. Gods. I'm gonna take a look at that 70 million one. Merrick Lure. Is this one, right? Got you. Show. So you listened to this a lot when you were younger, or? I mean, they've been around for a while, right? Or I mean, like, have you been listening to them for like a long time? Let's see. I got you. I got you. I could see it. Yeah, I don't even know what music taste I even have nowadays, to be honest. Nowadays, I just be coding for like however much time, and then I just put on whatever doesn't like obtrude too much. You know what I mean? Usually ends up being like some type of like Studio Ghibli playlist or something. It's I'm really trying to not put it in the constructor. Okay, you know what? Let's just make an init function. Let me put this one over here. Yeah, let me just make this function real quick. And I'm going to call this lifecycle. Lifecycle functions. And then we'll just make it init. I won't worry about a terminate for now. Okay. Put this over here, and then we'll say event q dot init, and I think it's on event. Client service. Ooh, I don't like that. Client service on event. Yeah, I'll see. Where are you from? I'm from America, like on the West Coast. Let's see. Wait, where is this on event function? Oh, it's right here. Okay. Oh, it's private, isn't it? Okay. I don't like that this is here. That's a weird code structure thing. Okay, you know what? I'm not gonna worry about it though. So, what I'm gonna go ahead and do no, I'm just hopping around. Let's see. Get client service init. Okay, we're gonna get rid of this. And let's head over to here. We'll get rid of this. And we'll just do it externally here. So connect the event slash function queues. Use them. Just look at the feature. Have you tried C++ 20 modules? I haven't had the opportunity to use them much, but it looks like a feature I've been waiting for or wanting. Yeah, I was actually looking at that pretty recently too. I want to use it. I think it would speed up my compile times by a lot. I've seen some demonstrations of people using it, but I haven't used it myself. Let me see. You know what? Since you're talking about it, I kind of want to take a look. Because I do use the 20 standard. Yep, export. Yeah, I think in my code, one of the best things about this is going to be once I use it, when I include stuff into my like say if I have like an audio library that I use inside of my engine, and I want to use that inside of like my final executable, I can just export the structs and the functions that how do I say, actually should be used externally, and then those dependencies don't need to get included into the final executable. That's going to be really nice. Yeah, the macros are so annoying. I mean, you can kind of deal with that by like undeffing it, but if you include like windows.h, like you're cooked, right? Oh, Suki, by the way, I just finished the song. It's pretty chill. Yeah, I can see the less Cowboys feeling. What does Fringance mean? I might also take a look at them later. Yeah, the only thing I worry about with these modules is that it's just such a different way of coding C++ that I feel like integrating it with others, or I don't know, people wouldn't be familiar with it since it's so new. That's the only fear I have with it. But otherwise, the benefits are so nice. The compile times being sped up is going to be great. I've seen people wrap Windows.h in an exported namespace, so it's not all bit global. Okay. Yeah, fair enough. Fair enough. I think. Wait, let me see. Where do I include? Yeah, I'm probably guilty of this sin somewhere. .h. Oh no. Let's do Windows.h. So, WhatsApp API. This is OpenAL soft. That's fine. B2. Okay, this is the implementation file. Wait, no, this is the dependency. So, wait, no. That's so annoying. Oh, there we go. Got lost for a second. Okay, so dependencies, let's close that. Okay, I only included once in my Windows backend API. So that's here. So where do I include this? Let's find that. Windows backend API. Okay, I use it for here. This is, what is this file? Windows utilities. So I have this in a separate Windows file. So that one's fine. Entry, I have an entry point. That's, no, wait, that's fine, because I need it for the WinMain. And then in projects, this is an implementation file too, so that's fine. But what am I using it for? This shouldn't be here. I am going to move this out. This is kind of gross. I'm not going to lie. And also in script service, yeah. So this one I know I do it for DLLs because of the way I have my hot reloading for my scripting system. So this one I have to have Windows in, but I can probably abstract this into like an API section. Let's see. I've seen, although you may be able to do that with includes, you know. Yeah. I mean, for the most part, I'm just trying to make sure that if I do include something, that it ends up in this API section over here. because this is specific for like platform things and things that are unique for some type of subsystem, right? That's not really handled by my engine. Or just like a low-level dependency. Nah, I don't have a custom ECS. I do want to. Because I do want to have some better memory visualization. But no, I use a ent. So why do I include base here? That's interesting. Should probably take a look at that. Yeah, I do want to get my own custom ECS. Just recently I added some like linear allocators, some stack allocators, or a stack allocator and a pool allocator. I've been messing with adding, like I have this little gen alloc. This is just a wrapper around malloc. But what I really want to get working is this page alloc for like getting like virtual alloc and mmap working. Right now it doesn't work, but at some point I will get better control over my memory. Like automatic dependency detection with scheduling. Right. Yeah, massive time sink. Yeah, I can see that. that was kind of the reason why because I think I did start to write my own ECS, and then I realized how much work it was going to be, and I just went back to the regular one. But I think I was following the series of articles by the creator of Ent, the Skypack. But I would imagine it's very like rewarding to put it together, though. Oh yeah, he puts it on his github.io. Yeah, I was reading through these articles. He describes the system pretty well, but still. And I think he also talks about like the difference between his system and like the way Flax sets it up. How they use archetypes, and Ents uses was it like, it's been so long since I've read these articles, I can't remember how they do it here. But yeah, I really want to like visualize the memory. That'd be really nice to have. How would you set up automatic dependency detection? I could see that's its usage, its usability, but I've never gone about that type of thing. Right now, I've been trying to figure out how I can get rid of a lot of the singletons inside of my engine, because I feel like singleton is like the natural thing people do. They're like, oh yeah, like we need to have this resource that's generally available, so make a singleton. But it's just a global variable, and it makes testing and everything is testing hard, and then you have a bunch of coupling everywhere every time you use something in a random place. So I'm trying to get away from that. But I've been reading like a lot of like programming patterns, trying to figure out ways of like dealing with it, but I'm still kind of in the middle of that, so. I do kind of think none of the ECS out there are perfect for the core of a game engine, just too much time to make a really nice one. Right, yeah, that's fair. Yeah, and yeah, you also got to worry about like what well, I mean, I guess that just depends on what your goals are, right? Like if your goal is to release a game as fast as possible, I mean, I would assume you just use an existing game engine. But if you want to learn how these things like work, or you want to just do something and build it for fun, I mean, I feel like that's a valid reason too, right? But yeah, like, you gotta worry about where you spend your time. It's fair enough. I feel that. Okay, I'm back here. So all right, connect the event queues. So we're going to say S client M event queue, and we're going to say init on events. I don't know if I need to bind this. This is a class function, so I'm wondering, but it's a static function, so we can pass it. We pass it along, and then it gets added here, and then once that's good, we can go ahead and use this event queue. Okay, cool. So that was the only addition I needed to have. And then let's get back here. Okay. Process event queue, yeah. Okay, cool. And now let's make something for the function queue as well. That one should be a lot simpler. I made a magic templated builder function that takes in a function pointer that can read the arguments at compile time to deduce read and write dependencies. I forgot exactly how I did that. Templated builder function that takes in a function pointer that can read the arguments of time to deduce read and write dependencies. I feel like I saw someone doing something somewhat similar. It was one of those streamers I follow. He has like a dependency injection system for his as well. And I remember he had a lot of template code for that as well. Let me find him really quick. He hasn't released his engine publicly. I've been wanting to check out his code though. I also got to be careful with how much template code I add in, because I know that can get really messy if I don't watch it. How do I... But of course, you know, I do use templates in my code fairly often too, so... Yeah, AK Elements. I remember I was asking him how he sets up his dependency chains for his engine, and he had a lot of template code kind of putting them together. And yeah, he had function pointers too for it. I was also thinking of like sort of like a plugin system kind of design, because I do want to support plugins too. I forget what it's called. Design patterns. I don't want to run too much, but which design pattern was that? I think it was the bridge pattern. Yeah, but this one lets you like register a plugin, and then maybe you can provide the dependencies with that plugin, and then provide the app context back with it, and then it can do what it's got to do, right? And you can also provide like init functions, terminate functions, update. And as long as you keep those samey, right, like you don't change the signature too much, then you can just register them as function pointers, right? Let's see. But of course, this is at runtime, right? Yours are talking about at compile time. But it's a similar idea, I guess. Let me see. Traverse the systems and their dependencies and create a DAG that runs the system in a custom... A DAG that runs the system in a custom job system so they run in parallel. Bevy and Rest just for the ECS. Their ECS is a lot nicer and features than mine ever was, but mine has some unique features like spawning entities without sync points. Also allows runaway systems that aren't bound to frame installing, so I didn't need hacks. So fast loading and rendering could run over multiple game frames potentially. You can run over. There's a dedicated thread for rendering and a separate ECS world for rendering, which feels hacky to me. Yeah, and I feel like that's kind of how mine works right now too. That last message you sent about how Bevy does it. Templated builder function that takes in the function pointer that can read arguments. Okay. Do you post your code online, Gandev? I'd love to take a look at it because I feel like some of the bits are kind of going over my head. Like, what is a DAG? Oh, okay. Well, I don't want you to. I don't want to push you to like make it public or anything. That's your decision. Yeah, it's up to you. I was just curious because of what you were saying. Oh, directed async. Let's see. Organization of a series of activities. The order of the activities depicted by a graph, which is a set of circles. Activity, some of which are by lines. One vertex to another, such that following those directions will never form a closed loop. Yeah. Order by arranging the vertices as a linear ordering that is consistent with the edge job. Arrange analogy. Graph each has its orientation from one vertex to another. Path and there's a sequence of edges. Said to be reachable from another vertex when there exists a path that starts from you and ends at. Okay, that's the mathematical definition. I got you. Reachable, transitive. Okay. Okay. I mean, I can see the structure. Let me see what we were talking about in context. So traverse system and dependencies and create a DAG that runs the system in a custom job in parallel to all cores. A DAG that runs the system in a custom job, so they run in parallel. Want all the business automatic. This one. Yeah, I'm just reading your comments right now. Read arithmetic about terms to do. Reverse the systems and dependencies. Just using queue for all jobs. Atomic counter. So if all prerequisite jobs finish, the last job pushes the new job. And the jobs are just functions basically so they run the systems. Okay. Concurrent queue for all jobs. And the jobs are just function pointers basically so they run the systems. Okay, okay. Wait, and then what is the job system for specifically? Like, what's like the external usages of it? Because I can picture it in my head, like with the DAG and everything, and then the atomic counter to make sure that the prerequisites are done so you can move forward. I get that. Was this for the ECS or is this just a general job system structure? That's interesting though. Also, I guess I'm taking a stretching break. And then also the ideas for the system, did you just throw it together one day, or did you have like specific research you went through? Because if you just put this together by yourself, that's really cool. I mean, either way is really cool, but I'm just kind of putting together the dots in my head right now. Okay, the ECS uses the job system. I got you. That kind of looks like job NQ. It returns a handle that can be used to wait. The return value. Or... Okay. No, I got you. And yeah, that makes sense. Yeah. Magic builder function that takes... That's interesting. So for the job system, and I'm assuming you have like a thread pool or something for taking care of the job. So you would just choose a thread, and then it picks up the job. And of course, everything's atomic, right? So once you determine if enough of the prerequisites are done, you just, or it just decrements the counter, right, until it's 0, and then you move along, right? Okay, so then you can do you can work on systems that are, you can work on jobs that are dependent on each other, but you can divvy out other ones that are not. And the read and like the parameters and the return values are determined at compile time based on. That's interesting. Yeah, that's pretty cool. Like task graph in real and optimize it a bit more, but that never made it mentioned. Using results from other jobs, and those jobs create more jobs, and it's pretty nice. No, yeah, I mean, I could see it. It's nice that you talked about the DAG, because I can really visualize it. So again, like, you getting information about this, you just researched? You looked at like how Unreal Engine does it, you looked at other systems and kind of just put it together? That's really cool. I'm just wondering, like, if I wanted to go ahead and read about this type of system, where would I go? Because you got me curious. Zoc D, hey, how's it going? Welcome to the stream. Sorry, I'm talking to Gan Dev about he's talking about his job system and him putting together his own ECS. So it's got me a little curious. You should be able to see it on the stream though. I have everything there. Or if you look on the actual like stream itself, I don't share them on the actual Twitch or whatever, or versus YouTube. But yeah, thanks for coming by. If you have any questions, let me know. I'm working on some networking code right now. I'm not a dev, I'll just lurk and listen to while doing Slayer tasks on RSC Classic. RSC, what is RSC Classic? You got me curious. RSC Classic. Oh, RuneScape. Okay, I got you. Okay, do your thing. I understand that MMO grind. There was an article on creating a job system in Rust that I saw a while ago. I'll see if I can find the link. This might have been it. Oh, okay. Well, don't feel too pressured, but you just got me curious. I've never put together like a formal job system. I just have a simple like single-threaded one that takes care of stuff. You can just send stuff to it asynchronously and then does the thing. But nothing more complicated than that. Yours, you have like dependency graphs and everything. That's crazy. Real quick though, guys, I'm gonna use the restroom. Probably like 2 minutes. But I'll be right back. Be right back. All right, I'm back. Thanks for the follow, Zakti. Appreciate it. I don't know if I earned the follow, but yeah, I hope the background helps you with your grinding. Let's see. Actually, maybe not. There's a toy engine if you want to check it out. It likely doesn't work. The moment as I broke some things a bit ago, has a custom Vulkan renderer as well, but it's really basic. Oh, I got you. Well, I mean, if it has that system, I'll take a look. I might look into just different job systems. I don't think I have a need for it right now, since my games are pretty simple. But I would like it for some research information. Maybe rewriting the current one I have at some point. Systems. Game engine? I remember, what's his name? I've been following Kohi. Yeah, Travis Vernon. I know he has a job system, like a very simple one. But I never had a chance to look at it. Oh, he has a priority thing. Okay. Job info. Config. I'm just reading through. I never took a chance to look at this. I always forgot to. Submit. Create type. Oh yeah, I'm sorry if anyone is like watching and like waiting on me. I'm kind of like chilling and just going through and learning and stuff. So I plan on making some videos covering what I get done with the engine at some point, but I'm kind of taking my time because I want to get a little bit more done before I post another video about it. Also, don't mind me, I'm just yapping. Right, yeah. Sometimes I look at his code to kind of find some stuff. I'm going to take a look at his job system at some point. This is where I got the inspiration to start working on memory management. So, as a custom local target is less than 400 lines of code, you can find it there. It has some pretty. Oh wait, did you link it? I don't think I saw the link. If you did. It's less than 400 lines. But how they're used in production. There was one from Naughty Dog called Games from they got the performance on the time. From Naughty Dog. Oh, you sent it again? Yeah, on my chat, it doesn't pop up, but maybe I can figure something out. Usually links work. That's kind of weird. I will take a look at that GDC talk though you're talking about. Oh yeah. YouTube might be filtering it. I gotta take a look at that. How else? Can you? Is it on GitHub? Can you just send me the name and the repo name? I can find it, like a separate strings or text or whatever. But yeah, let me take a look at these GDC. I might save them for later. You said there was one from Naughty Dog called Optimizing Games with Fibers. Optimizing Games with Fibers, GDC. Yeah, it's a VPN, that's not my IP. But sometimes this thing likes to do this. Let's see. I always forget how to add a Is it really? The bookmark system always kind of annoys me with this. All right, well, whatever. Let's just go ahead and save this. And I'll just put in engine links for now. I'll organize it later. And then you said another one. You said Halo Infinite. GDC Halo Infinite. Oh, I'm assuming that's you, Azartus. I'm assuming you're Gandev. But yeah, I got the link though, if that's it. Ah, gotcha. Do you know what the name of that GDC talk is for Halo Infinite? Wait, how do I okay, I want to make sure I remember this is for job system. Chrome be annoying me with this. Oh, okay, there we go. So, delete engine links, new folder. There we go. Job system. And then okay, I don't know, somewhere there. I hear my cat meowing. Let me go check on her. Okay. Okay, well, paralyzing. Where did I put the... Oh, job system is right here. Okay, there we go. And then you said how to... Oh, I think I've seen that talk. How small opened... Or I haven't, like, watched it, but I've seen... what is it? The name before. Is it this one? And then for how do I get rid of this? Shaders, assets, plugins, source private. Oh, this is just the main. I got you. Shaders, third party. This is just dependencies, right? I can go in. Yep. Plugins, assets. Okay, I'm assuming plugins then. My cat's drinking my water. Okay. You thirsty, kitty? Yeah, she's getting old. She's like 18 years old now. Almost 19. She could, in 2 more years, she can drink. At least in the USA. I mean, that's good. I like that everything's in plugins. Very distinct sections. Job system. Do you know if the name of it is like job? Yeah, you said it's been a while, right? Yeah, I'm assuming it's in core. That seems like a core system. Bitmask, asset manager, define, math, memory. Fair enough. RTTI, static reflection, traits, types. Task graph, okay. Gameplay framework. Everything has its own CMake. I feel that. Yeah, I was about to say, this looks like it, yeah. Wake up. Okay. I'm gonna go ahead and save this one. I'll take a stronger read through later when I'm like really getting into it. Wait, give me a sec. You okay, kitty? Yeah, I saw you had a few other ones, types and type traits too. That looked interesting. Yeah, I might take a read through at some point. Especially when I'm doing like job systems and whatnot. Yeah, I just don't know like where to start with these types of things, you know? Event queue, function queue. Okay, let's see. Where am I at with, I think about 4 hours and 20 minutes. Okay, there we go. But yeah, thanks for all the resources though. I appreciate it again. Event queue. ACS. I'm trying to think of where I should put this. I guess I'll just put it in core. I just throw stuff I don't know what to do with in core, but I'll figure it out. No, everything I've learned is just online. I do have a degree in computer science, but that's about it. Kind of one of the people that's what is it called? Or out from the industry. Or I got my degree and then job market, you know. So I've just been coding. I guess I'll put it in core, sure. Function queue. agpch.h. Okay, so now I need to figure out how I use this, and I can abstract it into like an object. That'll be nice. So how do I use this? I mean, basically you just submit to the function queue, use this mutex, and add the function, right? And then when you call the function, just process the function queue. And then here I get this local function cache, which is a little expensive, but you get it, you get the mutex lock, you move the data over, and then you call the function. And that's just so I don't have any weird recursive calls inside of the job or whatever, or when I handle it, right? Because I've had that happen before. So it doesn't need to really hold too much state other than the mutex and the actual function queue. The event queue needed to hold the function pointer. Also, I didn't realize how expensive these function pointers were, or how much like memory it uses. This is 64 bytes. I know it's not like insane, but like it's a decent amount compared to like a normal function pointer, which is just like 8 bytes. It's an 8 times difference. Jeez. I mean, I know it holds a lot more state and can acts more like a closure, but still. Yeah, let me just copy and paste this, and I'll get rid of the stuff that's not necessary. Let's see. Event queue. Event queue. And then function queue. Yeah, I recently switched over some of my stuff to like standard function pointers. I just hate the syntax, but I can't argue with the benefits though. Hash include, but for things like UI, where I'm like my editor UI, where I'm not really worried about the data itself, and it's in the editor, they're pretty convenient. Especially if I know the state of everything is going to be fine. It's a big if though. Vector. It's expensive. It's pretty easy to make something like a std function ref that state that doesn't own the allocation. Doesn't own the allocation. Or you use templates with a C++ concept to constrain it to be a callable. And then just right. It's pretty easy to make something like a std function ref that takes callables that own allocation. Memory. Right. C++ 20 concepts. I don't think I've ever used that one before. C++ 20 concepts. Include generic lambdas or templated functions associated with a constraint. Hashable. Yeah, I haven't gotten too much in this. Do we even call that metaprogramming? I don't think that applies here. Is base of. Templates. Let's see. Okay. Yeah. So it was in the template section. I gotta take a read through this. Ref that stores a function pointer and a void pointer basically, and static cast it with the function pointer. Template instead of, so it will throw errors saying something like X does not constrain to concept callable instead of a paragraph of errors. This is also the ID. Read underlines before compilation. Like if. Okay. I haven't gotten too much into like template programming, except for like just like basic usages. Do you think if I just ran through this section, I'd have more of an understanding? I feel like, oh, concepts ECS. Oh no, well, I mean, because I'm not super familiar with like template programming. Like I do use it, but very lightly for like the very simple cases. Do you think running through this section would make me comfortable with that? I don't know. It's just new to me, so. Yeah, that's kind of how I feel too. Because like I know most of this stuff. I've went through like what is it? Learn CPP. I've when I was first learning C++, I went through this entire website. Oh my god. Okay, fine. I'll take the cookies. Yeah, I went through this whole website, and then after that, I just started working on my projects. Right. But I feel like there's so much to learn with C++ that it's like, ugh. Okay, so you say concepts is just a superior version of that one. Okay. Okay. I might make a note for myself too to like take a look through this. Ooh. It's pretty expensive. It's easy to make something like std function ref that takes callable with state. It doesn't own the allocation. Use templates with plus 20 concepts. Pointer and a void pointer. Cast it with the void pointer. Oh, you have it in types HPP. Okay. Doesn't own the allocation. Ref that Text callable state on the allocation. Callable. On memory, that's just kind of a callable ref that stores function and avoid part basically. It will throw an error saying something like just not constrained constant callable instead of a paragraph error. To SD vector. Okay, wait. So one thing I'm trying to understand from what you said earlier, and maybe I'll give you like my current understanding of how all this works, and then maybe we can go from there. And sorry if I'm like asking a lot of questions, but it just got me like very curious. But because I'll get to this in a second. Let me go ahead and build this anyways. So when you, and let me include this just for like, actually, let me go to my little testing section and I'll do it there, since that's a bunch of throwaway code anyways. Okay, let me go to this init. Okay, so just the debug globals, I don't want that. I want the general testing. Here we go. Okay, so my understanding, right, with this is that we have an SD function, right, and then void, whatever, right, func pointer, right, and then you can associate this function point, like if you have a lambda, if I had some state right here and I had like int a is equal to 5, and then I did like a reference here, right, and I said a is equal to 10, right? Of course, this function pointer doesn't own this, right? It just references it with the reference, and you can do that more explicitly, right? But if you held this function pointer and called it somewhere else, it would still know about this, even if this fell out of the stack, right, and then became unusable memory. But of course, this function pointer doesn't own this memory. Like this pointer doesn't own this memory, but it holds reference to it, right, inside of its state, right? So it holds the actual function call itself, and it also holds the state of this, right, a reference to it. You can also like make a copy of it too if you wanted to, right? And then like a standard like function pointer would be like, I always forget the syntax for these things, but if I went to wrapped data and I went up here, where did I put it? These are wrapped changes. Don't mind these are kind of garbage. I was gonna change those anyways. But yeah, I have a couple type defs for some function pointers, and then I put it here. Okay, you would give it a number like pointer, right? So then this one doesn't hold any state, right? It's just a raw pointer, and then if I associate it with a lambda or something, or if I associate it with a function, it would just have the function itself, and it can't associate state with it, right? So it's very light. You were saying something about like allocations with it. What did you mean by that? Like, this is kind of my limit of my understanding with this. So it's a smart pointer. Okay, yeah. CT shared. Okay, so it's a shared pointer, and then you can you can provide like the memory for it. Or wait. Hold on. It's a shared pointer to basically an std function, so it still holds the state. Or let me read what you were saying too, because it has the small string optimization where if the lambda you pass in has a size smaller than some string, it stores it inline structure. Right? Oh. Oh, okay. So for local complex that don't need to store, you can have reference to the basically so. Location if 64-bit reference. It stores its own memory and handles it like a smart pointer. Oh, okay. Here's a reference. Memories that stores its own memory and handles it like a smart pointer. The reason std function is 64 bytes is because it has small string optimization where it's a lambda you pass has a size and some size. It stores it inline in the structure. Otherwise, it makes a heap allocation to store the rest of it. Okay. It makes a heap allocation to store more data, and it's sort of like a union. When function ref, with function ref, instead of copying the lambda data into the std function, it just stores a pointer to the data of the lambda. Oh, okay. Oh, okay. Because the lambda is defined inside of the what is it called? The program data, right? There's like a program because it has to have that actual what is it? That actual function somewhere inside of the actual program definitions, right? So you just make a reference to that instead of making a full copy, and then potentially doing more heap allocation if the size of it goes over. Okay. There's instead of copying lambda data, so it's like two pointers, one for the function pointer and another for the data pointer. So no allocation is required. Obviously now you can't have the function ref lifetime. Yeah, but that's like a whole, right, I got you. Because the function ref lifetime, that's a separate problem you have to deal with, just making sure that whatever you're calling isn't null. But yeah, I got you. You're talking about the underlying data of the lambda itself, or of the function. So again, the function ref that you're talking about, the one you put together, that one would just take a reference to the actual lambda, and then from there you can you don't have to make a copy. I got you. Auto args, std forward args. Look, I had this somewhere. Did I do something similar? Let me see. KG find class. Yeah, where is this defined? Oh, is that what this is? Okay. Yeah, because I use this. That's why I was like, wait, I know that. Oh, okay. Decal type args, yeah. Because I remember I picked this one up at some point. So, okay. So you said you had an implementation of this somewhere in your code. It was in the types section. Types.hpp. I don't know why I walked that back. Let's see. Types.hpp. There we go. std allocator arrays, std vector. Yeah, fair enough. Span, static array, variant. Map. Oh, okay, so you have using definitions for all these. Fair enough. Function. This one. Function ref. Const expert params, return params. It's a parameter pack for that one. Okay. I thought I know what that was, but I didn't. And then you have overload for optional, but this is what you're talking about with this, right? Predicated const type. I'm just looking through the rest of your stuff. Just kind of curious. Details. String literal. Number pointer. Notice card, fill that. Wrapper around type. Okay, I'm gonna take a look at this too then. I don't know if this applies to this job system. It's a, I'll just store here anyways. Within the function pointer. I'm doing some type erasure over the void pointer data. So then when you call, where's ref? Okay. Oh, you have a Clang thing too. Okay, for sure. So I'm assuming you use Clang. Kitty, you want to go out? Let me let you out. Fair enough. And then it's already cross-platform, right? Yeah, I feel it. Let's see. Oh, I was kind of confused. I was like, wait, is this an initialization list? It is an initialization list. Okay, so data reference to other, yeah. Oh, okay. Yeah. This one goes over this. No, I mean, fair enough. Yeah. Also, you can use the tool they have as well. Okay. Yeah, I think I might, I gotta get more comfortable with some of this template stuff though. I might take another look at my at the documentation and then come back and try to really understand this. Because I get the gist, but some of the like static decay stuff, some of the forward, and then the auto with the const. I mean, I get const expert, but I get but I gotta get more comfortable with this. Yeah, like some of the stuff goes over my head, so I'm trying to like I probably have to research it a bit. Okay. Ooh. Const volatile. Oh, it removes all of those. I got you. Okay, okay. All right, but I think I'm getting towards the end of my stream. I think I'm gonna go ahead and end it. I think our brain's getting kind of tired. And I think I'm gonna finish what I was working on off stream. But I will take a look into the resources off stream. But yeah, my brain's not really processing anymore. Yes, I'm gonna. Oh wait, just give me a sec. Ooh, okay. So let me go ahead and if zero this one. If zero and hash and let me do the same for this one. Hash if zero hash and if. Okay. All right. Here we go. Okay. Yeah. Fair enough. So I'll go ahead and commit off stream. Let me see. Yeah, I haven't made any changes to game code. I'm still pretty much where I'm at. I think over the next week I will finish up integrating the networking code. And then I'll go ahead and showcase what I got done between then. Talk about when the next stream. So yeah, next stream should be on Friday. It'll be 5 hours again, like the stream was. And yeah, I think that's gonna be. I think that's it. All right, so thanks for everyone coming by. Thanks, Gandev. I learned a lot, so I will be looking at those off stream. No, yeah, and then like, oh yeah, it's a lot cleaner to work with, right? I can see it. I think I have the same thing with my refs. Where is it? Where's ref? Yeah, a lot cleaner to use. But I feel it. All right, yeah, all right, but I think I'm gonna call it. So yeah, thanks, everyone sticking by and whatnot. If you watch this on YouTube, thanks for coming by and watching. And yeah, it's gonna be it for me today. So, all right, see you guys.